There is a quiet wonder in the world, a gentle curiosity that stirs beneath the surface of everyday life. In the hush of evening and the soft glow of starlight, questions arise and drift like leaves on a calm stream. What shapes the patterns of the clouds? What stories are written in the stones beneath our feet? How does the universe whisper its secrets through the language of atoms, tides, and time? Here, the journey is unhurried. Each topic is an invitation to wander slowly, to listen deeply, to notice the subtle connections that bind all things together. From the smallest particles to the vastness of the oceans, from the silent birth of stars to the intricate chemistry of life, every subject is explored with care, patience, and awe. This is a place for gentle exploration, a space where knowledge is not a race, but a quiet unfolding. The world is revealed not in shouts, but in whispers. Not in haste, but in the slow turning of pages and the soft rhythm of discovery. Here, science and story meet, and the complexity of the universe becomes a soothing tapestry of patterns, cycles, and meaning. Welcome to the sleepy knowledge, where curiosity is a comfort, and every question is a doorway to wonder. In the beginning, there is only silence. Not the silence of a quiet room or a sleeping world, but a silence so complete that even the idea of sound has not yet been born. Darkness stretches in every direction, not as an absence of light, but as a canvas that has never known illumination. There is no up or down, no before or after, no here or there. The universe, as it will one day be known, is still a secret, hidden within a single infinitesimal point of singularity, where all the energy, all the matter, all the laws of nature are compressed into a state beyond comprehension. Within this singularity, possibility itself is waiting. Every star, every planet, every living thing that will ever exist is contained in potential, folded into the fabric of nothingness. The tension is subtle, a quiet anticipation that cannot be measured or described. It is as if the universe is holding its breath, poised on the edge of becoming. Then, without warning or fanfare, the silence is gently disturbed. The singularity begins to expand, not with a violent explosion, but with a soft, steady unfolding. Space and time, inseparable and intertwined, begin to stretch outward. The first moment of existence is not a bang, but a whisper, a delicate ripple that moves through the void, carrying with it the seeds of everything to come. As the universe expands, it cools. The unimaginable heat of the earliest instant begins to fade, and with this cooling, the first particles emerge. Protons and neutrons, the building blocks of matter, appear in the newborn cosmos. They are simple, yet profound, for from these humble beginnings, all the complexity of the universe will eventually arise. The particles drift through the expanding space, their paths shaped by the subtle laws that are only now coming into being. The early universe is a place of transformation. Energy and matter are interchangeable, shifting from one form to another, in a dance that is both chaotic and ordered. For a brief moment, the cosmos is filled with a dense, hot plasma fog of particles and light, so thick that photons cannot travel far before being scattered. The universe is opaque, its secrets hidden within this glowing mist. But even in this opacity, change is underway. As the universe continues to expand and cool, the particles begin to combine. Protons capture electrons, forming the first atoms, hydrogen and helium, the simplest elements. These atoms are the first stable structures in the universe, and their formation marks a turning point. The fog begins to lift, and for the first time, light is free to travel across the cosmos. This ancient light, the cosmic microwave background, will one day be a faint echo of these earliest moments, a silent witness to the universe's birth. The expansion of space is not uniform. Tiny fluctuations, almost imperceptible, ripple through the fabric of the cosmos. These variations in density are the fingerprints of creation, the subtle imprints left by quantum processes in the earliest instance. In some regions, matter is slightly more concentrated. In others, it is more rarefied. Over time, these small differences will grow, shaping the large-scale structure of the universe. The universe, still young and delicate, is a place of profound simplicity. There are no stars, no galaxies, no planets, only a vast sea of hydrogen and helium, bathed in the afterglow of creation. Yet within this simplicity lies the blueprint for everything that will follow. The laws of physics set in motion in these first moments will guide the evolution of the cosmos for billions of years to come. Time flows gently forward, each second bringing new changes. The universe continues to expand, its temperature dropping with every passing moment. The energy that once filled every corner now spreads thin, and the forces that govern matter begin to assert themselves. Gravity, the weakest of the fundamental forces, becomes the architect of the cosmos, drawing matter together in a slow, patient embrace. In the vastness of space, clouds of hydrogen and helium begin to gather. These clouds are diffuse, they're atoms, separated by great distances, but gravity is persistent. Over millions of years, the clouds grow denser, their centers collapsing under their own weight. The temperature rises once more, and in the heart of these collapsing clouds, a new kind of transformation begins. Nuclear fusion ignites, and the first stars are born. Their light pierces the darkness, illuminating the universe for the first time. The birth of stars marks the end of the cosmic dark ages and the beginning of a new era. These stars are massive and short-lived, their lives measured in millions rather than billions of years. In their cores, hydrogen is fused into helium, releasing energy that shines across the cosmos. The first stars are not alone for long. Their light and heat begin to shape the surrounding gas, triggering the formation of new stars and eventually the first galaxies. The universe, once a featureless expanse, becomes a place of structure and variety. Galaxies form, each one a collection of stars, gas, and dust bound together by gravity. The cosmic web begins to take shape, a vast network of filaments and voids that stretches across the universe. The story of the universe's birth is one of patience and persistence. There is no rush, no urgency, only the slow, deliberate unfolding of possibility. Each stage builds upon the last, every change setting the stage for what is to come. The silence of the beginning is not emptiness, but a canvas upon which the universe will paint its intricate patterns. As the first stars live and die, they forge new elements in their cores. When they reach the end of their lives, they explode in brilliant supernova, scattering these elements across space. The debris from these explosions enriches the surrounding gas, seeding it with the building blocks of planets and life. The cycle of birth and death, creation and destruction, becomes the rhythm of the cosmos. The universe is now a place of light and shadow, of order and chaos. Galaxies swirl and collide, stars are born and die, and the elements forged in the hearts of stars begin to gather into new forms. The journey from nothing to something, from simplicity to complexity, continues with each passing moment. Throughout this unfolding, the laws of physics remain constant. The same forces that shaped the earliest particles now govern the motion of galaxies and the formation of stars. The universe is a place of unity, every part connected to the whole by the invisible threads of gravity, electromagnetism, and the nuclear forces. The patterns that emerge are not random, but the result of deep, underlying order. The cosmic microwave background, the afterglow of the universe's birth, continues to fill space with its faint, persistent light. It is a silent witness to everything that has happened, a record of the universe's earliest moments preserved in the fabric of space itself. This light, stretched and cooled by billions of years of expansion, carries with it the memory of the beginning. As the universe grows older, new possibilities arise. The first galaxies merge and grow, their stars gathering into clusters and superclusters. Black holes form in the hearts of massive stars, their gravity so intense that not even light can escape. These black holes become the engines of galaxies, shaping their evolution over cosmic time. The universe is vast beyond imagining, its scale measured in billions of light years. Yet every part is connected, every event a part of the larger story. The birth of the universe is not a single moment, but a continuous process, an unfolding that began in silence and continues to this day. In the quiet of the beginning, the seeds of everything are sown. The elements of matter, the flow of time, the laws of physics, all are born in these gentle moments, their origins woven into the very fabric of existence. The darkness is no longer empty, but alive with potential, every corner filled with the promise of discovery. The journey from the singularity to the first stars is a story of transformation, of energy becoming matter, of chaos giving way to order. It is a story written in the language of physics, told in the patterns of light and shadow, of expansion and collapse. The universe, once a whisper in the dark, has become a place of wonder and possibility. As the first chapter of the cosmos draws to a close, the stage is set for new stories to unfold. The elements forged in stars will gather into planets. The forces that shaped galaxies will guide the formation of solar systems, and the quiet unfolding of the universe will continue, carrying with it the promise of life and consciousness. The silence of the beginning is never truly broken. It becomes the background against which all things are measured, a reminder of the gentle, persistent unfolding that gave rise to everything. The universe, having emerged from its silent beginning, now stretches outward in all directions, a vast and cooling expanse. The first light, freed from the dense fog of particles, continues its journey, filling the cosmos with a gentle afterglow. In this immense and quiet space, the simplest atoms, hydrogen and helium, drift in great clouds, their presence subtle, yet profound. These atoms, born in the earliest moments, are the universe's first building blocks. Scattered like seeds across the cosmic field, time passes in silence, measured not by clocks, but by the slow unfolding of change. The universe is still young, its story just beginning to take shape. The hydrogen and helium atoms, so light and unassuming, float through the darkness, rarely meeting, rarely touching. Yet in the vastness, gravity's patient hand begins to gather them, drawing them together into denser regions. These gatherings are the first hints of structure, the earliest signs that the universe will not remain a featureless sea forever. Within these growing clouds, the temperature and pressure slowly rise. At first, the changes are almost imperceptible, a gentle thickening of the cosmic mist. But as more atoms are drawn together, the centers of these clouds become hot and dense, the conditions quietly shifting toward something new, deep within. These hidden hearts, a transformation is about to begin, a process that will change the universe forever. Nuclear fusion, the quiet alchemy of the stars, is set in motion. In the core of each dense cloud, hydrogen atoms are pressed so closely together that their boundaries blur and the strong nuclear force takes hold. Protons merge, forming helium and releasing energy in the process. This energy, born in the heart of darkness, radiates outward, and the first stars ignite. Their light, pure and brilliant, pierces the cosmic night, marking the end of the universe's dark ages. The birth of the first stars is a gentle revolution. Their light travels across the emptiness, illuminating the clouds of gas and dust that surround them. The universe, once a place of silence and shadow, now glows with the soft radiance of countless newborn suns. Each star is a furnace, quietly fusing hydrogen into helium, releasing energy that warms the space around it. The process is steady and patient, a slow transformation that will continue for millions of years. Within the hearts of these stars, The alchemy of elements unfolds. As hydrogen is consumed, the core contracts and heats up, allowing new reactions to take place. Helium atoms fuse to form carbon and oxygen, and in the most massive stars, even heavier elements are created: neon, magnesium, silicon, and iron. Each stage of fusion is a step in the quiet journey from simplicity to complexity, from the lightest elements to the rich diversity of matter. The life of a star is a story of balance. Gravity pulls inward, trying to collapse the star, while the energy from fusion pushes outward, holding the star in a delicate equilibrium. For most of its life, this balance is maintained, and the star shines steadily, a beacon in the darkness. But eventually, the fuel runs low, and the balance is lost. The star's fate depends on its mass. Smaller stars, like gentle candles, fade quietly, shedding their outer layers and leaving behind a core of carbon and oxygen, a white dwarf glowing softly in the night. The most massive stars, however, end their lives in spectacular fashion. When their cores are filled with iron, fusion can no longer provide the energy needed to support them. The core collapses in an instant, and the outer layers are blasted into space in a supernova explosion. For a brief moment, the star outshines entire galaxies, its light traveling across the universe. In the heart of the explosion, the temperatures and pressures are so extreme that new elements are forged: gold, silver, uranium, and more. These elements, created in the final moments of a star's life, are scattered into space, enriching the clouds of gas and dust that will one day form new stars and planets. The universe is now a place of cycles. Stars are born, live, and die, each generation enriching the cosmos with new elements. The material from one star becomes the building blocks for the next, and the process repeats, each cycle adding to the complexity of the universe. The elements forged in stars are not confined to the heavens. They drift through space, carried by winds and explosions, mixing with the primordial hydrogen and helium. Over time, these enriched clouds gather and collapse, forming new stars and eventually planets. The heavier elements carbon, oxygen, silicon, iron begin to play a larger role, forming the solid cores of worlds and the molecules that will one day give rise to life. The story of the universe is now written in the language of chemistry, each element a letter, each molecule a word in the unfolding narrative. The alchemy of elements is a quiet process, unfolding over millions and billions of years. There is no hurry, no rush, only the patient work of stars, forging the materials needed for the next chapter. The universe, once a simple sea of hydrogen and helium, is now a place of richness and variety, every atom a record of ancient fires. The journey of an atom is long and winding. A single carbon atom, forged in the heart of a massive star, may travel for eons through the emptiness of space. It may become part of a dust grain, drifting in the interstellar medium, or be swept up in the formation of a new star. It may find itself in the atmosphere of a planet, or locked in the crystal lattice of a rock. Each atom carries with it the memory of its origins, a silent witness to the history of the cosmos. The elements themselves are storytellers. Hydrogen, the most abundant, is the oldest, a relic of the universe's birth. Helium, too, is ancient, formed in the first minutes and in the cores of stars. Carbon and oxygen, essential for life, are the products of stellar fusion, their abundance a sign of the universe's maturity. Iron, the end point of fusion in massive stars, marks the boundary between creation and destruction. The heavier elements, rare and precious, are the gifts of supernova, scattered across the cosmos in the final moments of a star's life. The periodic table, so familiar on Earth, is a map of the universe's history. Each element is a chapter, each isotope a variation. On the theme, the patterns of abundance, The ratios of elements tell the story of stars and galaxies, of explosions and collisions, of the slow, patient work of time. The chemistry of the cosmos is a record of its evolution, a testament to the interconnectedness of all things. In the quiet spaces between stars, chemistry continues its work. Atoms and molecules drift through the cold darkness, occasionally meeting and joining to form more complex structures. Simple molecules, hydrogen gas, carbon monoxide, water, are found in the vast clouds of the interstellar medium. These clouds, cold and dark, are the nurseries of new stars and planets. Within them, dust grains provide surfaces for chemical reactions, allowing more complex molecules to form. Amino acids, the building blocks of life, have been found in these clouds, hinting at the universality of chemistry, that the cycle of creation and destruction, of fusion and dispersal, is the heartbeat of the universe. Every atom in every living thing was once part of a star, forged in the heat of nuclear reactions and scattered by the winds of change. The calcium in bones, the iron in blood, the oxygen in breath, all are gifts from ancient stars, carried across the cosmos by the patient work of time. The silence of space is not emptiness, but a stage for the quiet drama of chemistry. The elements, born in fire, drift through the darkness, waiting for the chance to become part of something new. The universe is a place of transformation. Every atom a participant in the ongoing story of creation. As the universe ages, the cycles continue. New stars are born from the ashes of the old. New planets form from the dust of exploded suns. The elements forged in the hearts of stars become the foundations of worlds, the raw materials for mountains, oceans, and life itself. The alchemy of elements is never-ending, a process that links the smallest atom to the largest galaxy, the simplest molecule to the most complex organism. The story of stardust is a story of connection. Every part of the universe is linked by the flow of matter and energy, by the cycles of birth and death, by the quiet work of chemistry. The atoms that make up a human body were once part of distant stars, their journeys spanning billions of years and countless transformations. The universe is not a collection of isolated objects, but a web of relationships, every part influencing and being influenced by the whole. In the gentle unfolding of time, the universe becomes more than the sum of its parts. The elements, forged in silence and scattered by explosions, gather and combine in endless variety. The chemistry of the cosmos is a symphony, each atom a note, each molecule a chord, each reaction a movement in the grand composition. The universe, once a simple sea of hydrogen and helium, is now a place of richness and possibility, every corner filled with the promise of new stories. The alchemy of elements is the foundation upon which all else is built. Without the patient work of stars, there would be no planets, no oceans, no life. The cycles of creation and destruction, of fusion and dispersal, are the engines of change, driving the evolution of the cosmos. The universe is a place of transformation, every atom a participant in the ongoing story of creation. As the chapter of stardust and silence draws to a close, the universe stands on the threshold of new possibilities. The elements forged in stars are ready to become part of something greater, to join in the formation of planets and the emergence of life. The quiet alchemy of the cosmos continues, each cycle building upon the last, each transformation a step toward greater complexity and beauty. The journey of the elements is far from over. In the next unfolding, the forces that shape galaxies and stars will guide the formation of worlds, and the chemistry of creation will give rise to the first stirrings of life. The universe, ever patient, continues its gentle evolution, each moment a testament to the power of connection and the beauty of transformation. The universe, now enriched with the elements forged in ancient stars, continues its slow, patient expansion. The afterglow of the earliest light still lingers, a faint memory of the universe's first moments, while clouds of gas and dust drift through the vastness, carrying within them the seeds of new beginnings. In this immense and silent expanse, a subtle force begins to assert itself, a force that will shape the destiny of all matter, guiding the formation of the grandest structures the cosmos will ever know. Gravity, gentle yet relentless, is the quiet architect of the universe. Unlike the explosive energy of fusion or the fleeting spark of chemical reactions, gravity works with patience, drawing matter together over millions and billions of years. Its touch is invisible, yet its influence is everywhere, binding atoms into clouds, clouds into stars, and stars into galaxies. The universe, once a scattered sea of particles, begins to gather itself, forming islands of light in the endless night. In the earliest epochs, the universe is a tapestry of subtle variations. Some regions are slightly denser than others, the result of tiny fluctuations imprinted during the universe's birth. These differences, though minuscule, are enough for gravity to begin its work. Over time, the denser regions attract more matter, growing ever larger, while the emptier spaces become vast cosmic voids. The universe takes on a new texture, a web of filaments and clusters stretching across unimaginable distances. Within these filaments, clouds of gas collapse under their own weight, forming the first galaxies. Each galaxy is a collection of stars, gas, dust, and dark matter, bound together by gravity's gentle embrace. The shapes of galaxies are as varied as the stars themselves. Some are graceful spirals, their arms winding outward in elegant curves. Others are elliptical, smooth and featureless, like cosmic eggs. Still others are irregular, their forms shaped by collisions and chance. The dance of galaxies is a slow, majestic waltz. Over billions of years, galaxies drift through space, drawn together by their mutual attraction. Some pass by each other in silent encounters, their stars barely disturbed. Others collide, merging in a slow-motion ballet that can last hundreds of millions of years. When galaxies meet, their shapes are transformed, spiral arms are stretched and twisted, clouds of gas are compressed, and bursts of star formation light up the darkness. The universe is a place of constant change, every encounter a new step in the cosmic dance. Within each galaxy, gravity continues its quiet work. Stars orbit the galactic center, their paths shaped by the mass of the galaxy and the mysterious presence of dark matter. The spiral arms of galaxies are not solid structures, but waves of density that move through the disk, gathering gas and dust and triggering the birth of new stars. The center of many galaxies is home to a supermassive black hole, its gravity so intense that not even light can escape. These black holes, though invisible, influence the motion of stars and gas, shaping the evolution of their host galaxies. The Milky Way, the galaxy that will one day cradle a small blue planet, is just one of billions. Its spiral arms are home to hundreds of billions of stars, each with its own story, its own journey through space and time. The Milky Way is part of a larger family, the Local Group, a collection of galaxies bound together by gravity. The largest member of this group is Andromeda, a spiral galaxy much like our own, destined to one day merge with the Milky Way in a slow, graceful collision. Beyond the Local Group, galaxies gather into clusters and superclusters, forming the largest structures in the universe. These clusters are connected by filaments of dark matter and gas, creating a vast cosmic web that stretches across the observable universe. The spaces between the filaments are immense voids, regions where few galaxies reside, their emptiness a testament to the power of gravity to shape the cosmos. The story of galaxies is a story of connection. No galaxy exists in isolation. Each is part of a larger whole, its fate intertwined with the fate of its neighbors. The universe is a network of relationships, every part influencing and being influenced by the rest. Gravity is the thread that weaves this network together, its pull felt across billions of light years. Within galaxies, the cycle of creation and destruction continues. Stars are born in clouds of gas, live out their lives, and die in explosions that enrich the surrounding space with new elements. The material from dying stars becomes the raw material for new generations, each cycle adding to the complexity of the galaxy. Planets form from the dust and gas left over from star formation, their orbits shaped by the gravity of their parent stars. The dance of galaxies is not always gentle. Collisions and mergers are common, especially in the crowded centers of clusters. When galaxies collide, their stars rarely meet head-on, but their gas clouds can crash together, triggering bursts of star formation. The shapes of the galaxies are transformed, their stars flung into new orbits, their gas compressed and heated. Over time, the merged galaxy settles into a new form, its history written in the patterns of its stars and the distribution of its elements. The universe is a place of balance and tension. Gravity pulls matter together, while the expansion of space drives galaxies apart. On the largest scales, these forces are in delicate equilibrium, shaping the evolution of the cosmos. The expansion of the universe, set in motion in the earliest moments, continues to this day, carrying galaxies ever farther apart. Yet within clusters and superclusters, gravity holds galaxies together, their mutual attraction overcoming the pull of expansion that the cosmic web, the large-scale structure of the universe, is a testament to the power of gravity. Filaments of dark matter and gas connect clusters of galaxies, forming a vast network that spans the observable universe. The patterns of the web are not random, but the result of billions of years of gravitational evolution. The distribution of galaxies, the shapes of clusters, the emptiness of voids, all are shaped by the invisible hand of gravity. Dark matter, though unseen, plays a crucial role in this story. Its presence is inferred from the motion of stars and galaxies, from the bending of light by gravity, and from the patterns of the cosmic web. Dark matter does not emit or absorb light, but its gravity shapes the evolution of galaxies and clusters. Without dark matter, the universe would look very different. Galaxies would not form, and the cosmic web would not exist. The dance of galaxies is a slow, ongoing process. Over billions of years, galaxies grow and change, their shapes and sizes, evolving as they interact with their neighbors. Some galaxies are torn apart by tidal forces, their stars scattered into the intergalactic medium. Others grow by accreting smaller galaxies, their mass and luminosity increasing with each merger. The universe is a place of constant motion, every galaxy a participant in the grand ballet of gravity. Within the spiral arms of galaxies, new stars are born from clouds of gas and dust. These regions, known as stellar nurseries, are the sites of intense activity where gravity gathers material and triggers the collapse of dense cores. The birth of a star is a quiet event, hidden from view by thick clouds of dust, but its light will one day shine across the galaxy, adding to the collective glow of billions of suns. The life of a galaxy is measured in billions of years. Over time, the rate of star formation slows as the supply of gas is consumed or expelled. The oldest stars, formed in the earliest epochs, drift through the galaxy, their orbits shaped by the mass and structure of the system. Some galaxies become quiescent, their star formation ceasing, their light fading as their stars age and die. Others remain active, their spiral arms bright with the light of young stars. The universe is a place of memory. The shapes of galaxies, the distribution of stars, the patterns of the cosmic web, all are records of the past, written in the language of gravity. Every collision, every merger, every burst of star formation leaves its mark, shaping the evolution of the cosmos. The universe is not static, but a living, changing system, its history unfolding over billions of years. The dance of galaxies is also a dance of time. Light from distant galaxies takes millions or billions of years to reach us, carrying with it the story of the universe's past. When we look at the night sky, we see galaxies as they were long ago, their light a message from a time when the universe was younger. The farther we look, the farther back in time we see, glimpsing the early stages of galaxy formation and the growth of the cosmic web. The story of gravity's embrace is a story of connection and transformation. From the gathering of gas into stars, to the assembly of stars into galaxies, to the weaving of galaxies into the cosmic web, gravity is the force that shapes the universe. Its influence is gentle yet profound, guiding the evolution of the cosmos with patience and persistence. The universe, once a simple sea of hydrogen and helium, is now a place of structure and variety. Galaxies swirl and collide, stars are born and die, and the elements forged in the hearts of stars become the foundations of worlds. The dance of galaxies is the grandest expression of gravity's power, a testament to the interconnectedness of all things. As the chapter of gravities embrace unfolds, the universe stands as a tapestry of light and shadow, of order and chaos. The patterns of the cosmic web, the shapes of galaxies, the cycles of creation and destruction, all are the result of gravity's patient work. The universe is a place of beauty and wonder, every part connected to the whole by the invisible. Threads of gravity. The journey continues, as the forces that shape galaxies and stars guide the formation of solar systems and planets. The chemistry of creation, set in motion in the hearts of stars, will give rise to new possibilities, and the quiet unfolding of the universe will carry on, each moment a step in the grand dance of existence, across the vastness of the universe, where galaxies swirl in gravity's embrace, and the cosmic web stretches from one horizon to the next. A quieter, more delicate traveler begins its journey. Light, born in the hearts of stars and the depths of ancient explosions, weaves its way through the darkness, carrying with it the stories of creation and change. Each photon, a tiny packet of energy, sets out on a path that may last seconds or billions of years, crossing the silent reaches of space with unwavering persistence. The journey of light begins in the most secret places, deep within the core of a star, where temperatures soar and atoms are pressed together with unimaginable force. Nuclear fusion releases energy in the form of photons. These newborn photons are not yet free to roam. They are trapped in a dense, seething sea of particles, bouncing from atom to atom in a chaotic dance. For thousands, even millions of years, a photon may travel only a few centimeters at a time. Its path is zigzagged through the crowded heart of the star. Eventually, after countless collisions and changes in direction, a photon escapes the star's core and begins its outward journey. Passing through the star's outer layers, it emerges into the open expanse of space, where the density of matter drops away and the darkness stretches on forever. Here, the photon is finally free, its path no longer hindered by the press of atoms and ions. It sets out across the universe, moving at the ultimate speed limit, nearly 300,000 kilometers per second, its energy and information preserved in the rhythm of its waves. Light is both a wave and a particle, a duality that defies ordinary understanding. As a wave, it ripples through the fabric of space, its frequency and wavelength determining its color and energy. As a particle, it arrives in discrete packets, each photon carrying a specific amount of energy. This dual nature allows light to interact with matter in subtle and varied ways, sometimes behaving like a wave, sometimes like a particle, always revealing new facets of its character. The universe is filled with light of every kind. Some photons are visible, their wavelengths falling within the narrow band that human eyes can detect. These are the colors of the rainbow, the familiar hues of sunlight and starlight. But most light is invisible, its wavelengths too long or too short for human perception. Infrared light, with its gentle warmth, reveals the heat of stars and planets. Ultraviolet light, more energetic, traces the birth and death of stars. X-rays and gamma rays, the most powerful forms of light, emerge from the most violent events in the cosmos: supernova, black holes, and the collision of neutron stars. As photons travel through space, they encounter many obstacles and opportunities. Some are absorbed by clouds of gas and dust, their energy warming the cold darkness or triggering new chemical reactions. Others are scattered, their paths redirected by particles and fields, their journeys lengthened by detours and delays. Some photons pass through the universe unimpeded, traveling for billions of years before reaching their destination. Each photon's journey is unique, shaped by the landscape of the cosmos and the events it encounters along the way. The story of light is also the story of time. Because light travels at a finite speed, it takes time for photons to cross the vast distances of space. When a photon from a distant galaxy reaches Earth, it carries with it a message from the past, a snapshot of the universe as it was when the photon began its journey. The farther away the source, the older the light, and the deeper into cosmic history we can see. In this way, light becomes a time machine, allowing us to look back across billions of years and witness the birth and evolution of galaxies, stars, and planets. The cosmic microwave background, the faint afterglow of the universe's birth, is a sea of ancient photons that have been traveling since the universe was only a few 100,000 years old. These photons, stretched and cooled by the expansion of space, now fill the universe with a gentle, uniform glow. Their presence is a silent testament to the earliest moments of creation, a record of the time when matter and light first parted ways and the universe became transparent. Light is also a messenger, carrying information about its source and the journey it has taken. The color and intensity of starlight reveal the temperature, composition, and age of the star. The patterns of absorption and emission lines in a spectrum tell the story of the elements present, the motions of gas and dust, and the presence of magnetic fields. Even the tiniest shifts in wavelength, caused by the motion of a star or the expansion of the universe, can reveal the secrets of distant worlds and the fate of galaxies. The interaction of light with matter is a dance of energy and information. When a photon strikes an atom, it can be absorbed, raising an electron to a higher energy level. The atom may then re-emit the photon, often at a different wavelength, sending it off on a new journey. In this way, light is constantly being transformed. Its energy passed from one form to another, its message altered and enriched by every encounter. On Earth, the journey of light shapes the rhythms of life. Sunlight warms the surface, dries the weather, and powers the growth of plants through photosynthesis. The changing angle and intensity of sunlight mark the passage of days and seasons, guiding the cycles of nature. The colors of the sky, the glow of the moon, the twinkle of stars, all are gifts of light, reminders of the connection between the cosmos and the world below. That the study of light, or spectroscopy, has become one of the most powerful tools in astronomy. By analyzing the light from distant objects, scientists can determine their composition, temperature, motion, and distance. The discovery of exoplanets, the mapping of galaxies, the measurement of the universe's expansion, all rely on the careful observation and interpretation of light. Every photon that reaches a telescope is a messenger from the universe, carrying with it a wealth of information waiting to be decoded. Light also reveals the invisible. Through the use of different wavelengths, astronomers can peer into regions of space hidden from ordinary sight. Infrared light penetrates dust clouds, revealing the birthplaces of stars and planets. X-rays expose the hot, energetic regions around black holes and neutron stars, Radio waves trace the structure of galaxies and the distribution of cold gas. Each form of light opens a new window on the universe, expanding our understanding and deepening our sense of wonder. The journey of a photon is not always straightforward. In the presence of strong gravitational fields, such as those near massive stars or black holes, the path of light is bent, a phenomenon known as gravitational lensing. This bending can magnify and distort the images of distant galaxies, creating arcs and rings of light that reveal the presence of invisible mass. Gravitational lensing has become a powerful tool for studying dark matter and the large-scale structure of the universe, allowing astronomers to map the unseen and explore the depths of cosmic history. Light is also subject to the expansion of the universe. As space itself stretches, the wavelength of traveling photons is stretched as well, shifting their color toward the red end of the spectrum. This redshift is a key indicator of the universe's expansion, providing a measure of distance and velocity for galaxies and quasars. The farther away a galaxy, the greater its redshift and the older the light we receive. In this way, light becomes a ruler for measuring the cosmos, a guide to the scale and age of the universe. The story of light is a story of persistence. Photons travel across unimaginable distances, through the emptiness of space and the obstacles of matter, carrying their message with unwavering fidelity. Some photons are absorbed and re-emitted, countless times before reaching their destination. Others travel straight and true, their path unbroken from source to observer. Each photon is a witness to the events of the universe, a silent participant in the unfolding drama of creation and change. The beauty of light is found not only in its journey, but in its effects. The colors of a sunset, the shimmer of a rainbow, the glow of the aurora are manifestations of light's interaction with matter. The play of light and shadow, the patterns of reflection and refraction, the dance of photons and electrons are the foundations of vision, perception, and understanding. Light is the bridge between the cosmos and consciousness, the medium through which the universe reveals itself to those who seek to know. In the darkness between the stars, light is a constant companion. Even in the emptiest regions of space, photons from distant galaxies and the cosmic microwave background pass by, their presence a reminder of the interconnectedness of all things. The universe is never truly dark. It is filled with the gentle glow of ancient light, the echoes of creation, and the promise of discovery. The journey of light is also a journey of transformation. As photons travel, they are absorbed, scattered, and re-emitted, their energy passed from one form to another. In the heart of a star, light is born from the fusion of atoms. In the atmosphere of a planet, it is scattered to create the blue of the sky and the red of the sunset. In the eyes of a living creature, photons trigger chemical reactions that give rise to vision, perception, and awareness. Light is the thread that connects the physical and the living, the cosmic and the personal. The universe, in all its vastness, is illuminated by the journeys of countless photons. Each one is a story, a message, a memory of the past carried into the present. The study of light is the study of the universe itself, a quest to understand the origins, evolution, and destiny of all things. Through light, the cosmos speaks, and through light, we listen and learn. As the chapter of light's long journey unfolds, the universe reveals itself as a place of beauty, connection, and wonder. The photons that travel across space and time are the messengers of creation, the bearers of information, the witnesses to the unfolding story of the cosmos. Their journeys are never truly finished, for each photon that is absorbed or scattered becomes part of a new story, a new journey, a new expression of the universe's endless creativity. The story of light is far from over. As the universe continues to evolve, new sources of light are born, new journeys begin, and new messages are sent across the darkness. The photons that travel today will one day reach distant worlds, carrying with them the memory of the present and the promise of the future. The universe, ever patient, continues its gentle unfolding, each moment illuminated by the persistent, unwavering journey of light. Beneath the grand sweep of galaxies and the luminous journeys of photons, a subtler world unfolds, a world where the rules of the very large give way to the mysteries of the very small. Here, in the quiet depths of reality, the universe reveals another layer of its hidden language. The familiar certainty of everyday experience dissolves, replaced by a realm where particles and waves blend, where uncertainty is woven into the fabric of existence, and where the most fundamental building blocks of matter and energy perform a silent, intricate dance. The story of this hidden symphony begins with the atom, once imagined as the smallest, indivisible unit of matter. For centuries, the atom was thought to be a solid, unbreakable sphere, the foundation upon which all things were built. But as curiosity and technology advanced, the atom's secrets began to unfold. Within its heart, a dense nucleus of protons and neutrons is surrounded by a cloud of electrons, each one moving not in fixed orbits, but in patterns of probability, their positions and energies described by the strange mathematics of quantum mechanics. In this quantum world, certainty gives way to possibility. The electron is not a tiny ball circling the nucleus, but a wave of potential, its location and momentum forever uncertain. The more precisely one is known, the less certain the other becomes, a principle known as Heisenberg's uncertainty. This is not a limitation of measurement, but a fundamental property of nature, a whisper of indeterminacy that shapes every atom, every molecule, every living cell. Particles, in the quantum view, are also waves. Light, which travels as a photon, can behave as a wave, spreading out and interfering with itself, creating patterns of brightness and shadow. Electrons, too, can act as waves, their paths bending and blending, their presence revealed only in the patterns they leave behind. This duality is not a contradiction, but a deeper truth, a sign that the universe is more subtle and interconnected than it first appears. The mathematics of quantum mechanics is a language of probabilities, of amplitudes and phases, of superpositions and entanglements. A particle can exist in many states at once, its reality not fixed until it is observed or measured. This superposition allows for the possibility of quantum tunneling, where a particle can pass through barriers it could never cross in the classical world. It allows for entanglement, where two particles, once linked, remain connected no matter how far apart they travel, their properties intertwined in a way that defies ordinary understanding. The quantum world is not confined to the realm of the very small. Its effects ripple outward, shaping the behavior of atoms and molecules, the chemistry of life, the properties of materials, and even the workings of stars. The fusion that powers the sun, the reactions that build DNA, the conductivity of metals, the transparency of glass all are governed by the rules of quantum mechanics. Their outcomes determined by the hidden symphony of waves and particles. At the heart of this symphony are the fundamental particles, the building blocks of all matter and energy. The standard model of particle physics describes a family of quarks and leptons, each with its own mass, charge, and spin. Quarks combine to form protons and neutrons, while electrons and their kin form the outer shells of atoms. These particles interact through the exchange of force carriers, photons for electromagnetism, gluons for the strong force, W and Z bosons for the weak force, and, perhaps, the elusive graviton for gravity. The strong force binds quarks together, holding protons and neutrons in the nucleus with a grip so powerful that it overcomes the repulsion of their positive charges. The weak force allows for the transformation of particles, enabling the fusion reactions that power stars and the decay processes that shape the elements. Electromagnetism governs the interactions of charged particles, the flow of electricity, the behavior of light. Gravity, though weakest of all, shapes the structure of the universe on the largest scales, guiding the motion of planets, stars, and galaxies. Yet even these forces are not the end of the story. The quantum world is filled with fields, continuous invisible presences that fill all of space. Every particle is an excitation of a field, a ripple in the underlying fabric of reality. The Higgs field, for example, gives mass to particles. Its presence felt everywhere, its effects revealed in the collisions of high-energy particles. The quantum vacuum, far from empty, seethes with virtual particles, pairs that appear and vanish in the blink of an eye. Their fleeting existence, a reminder of the restless energy that pervades all things. The language of quantum mechanics is subtle and precise, its predictions confirmed by countless experiments. Yet its meaning remains elusive, its implications profound. The act of measurement, the collapse of the wave function, the role of the observer, these are questions that continue to inspire debate and wonder. Is the quantum world a realm of pure possibility, or does it conceal a deeper, hidden order? Are the outcomes of quantum events truly random, or are they determined by laws we have yet to discover? The hidden symphony of the quantum world is not confined to the laboratory or the blackboard. Its effects are everywhere, shaping the world in ways both obvious and invisible. The colors of the sky, the sharpness of a diamond, the warmth of sunlight, the taste of salt, all are products of quantum interactions, the result of electrons moving between energy levels, of photons being absorbed and emitted, of atoms joining and separating in endless combinations. In the living world, quantum mechanics plays a role in the processes of life itself. The efficiency of photosynthesis, the navigation of migratory birds, the sense of smell, all may depend on quantum effects, on the ability of particles to tunnel, to entangle, to exist in superpositions. The boundaries between physics, chemistry, and biology blur, revealing a universe where the smallest and the largest, the simplest and the most complex, are deeply connected. The quantum world is also a world of potential. The technologies of the future quantum computers, quantum communication, quantum sensors are being built on the principles of superposition and entanglement, harnessing the hidden symphony to solve problems, transmit information, and explore the unknown. The promise of quantum technology is vast, its possibilities limited only by imagination and ingenuity. Yet for all its strangeness, the quantum world is not alien. It is the foundation of everything, the stage upon which the drama of the universe unfolds. Every atom, every molecule, every cell, every star is shaped by the rules of quantum mechanics, its properties determined by the interplay of waves and particles, of uncertainty and possibility. The hidden symphony is the music of existence, a melody that plays in every corner of the cosmos. The journey into the quantum world is a journey into the heart of reality. It is a journey that reveals the interconnectedness of all things, the unity of matter and energy, the subtlety of nature's laws. It is a journey that invites wonder, humility, and awe, a reminder that the universe is more mysterious and beautiful than we can ever fully comprehend. As the story of the hidden symphony unfolds, the universe reveals itself as a place of endless possibility. The waves and particles, the fields and forces, the probabilities and uncertainties, all are part of a grand design, a tapestry woven from the threads of quantum reality. The cosmos is not a machine, but a living, breathing system, its every part connected to the whole, its every moment a note in the ongoing music of creation. The quantum world is a world of whispers, of subtle hints and hidden patterns. It is a world where the boundaries between past and future, between here and there, between self and other, are blurred and shifting. It is a world that challenges our understanding, that invites us to look deeper, to listen more closely, to seek the meaning behind the music dot in the end. The Hidden Symphony is not just a story of particles and waves, of equations and experiments. It is a story of connection, of unity, of the profound beauty that lies at the heart of all things. The universe, in its quiet depths, sings a song of possibility, a song that echoes through every atom, every star, every living being. The journey continues as the forces and fields of the quantum world shape the evolution of the cosmos. The chemistry of creation, the dance of galaxies, the birth of stars, all are guided by the Hidden Symphony, each note a step in the unfolding story of existence. The universe, ever patient, continues its gentle evolution, each moment a testament to the power of connection and the beauty of transformation. In the depths of the quantum world, where particles and waves blend in a hidden symphony, the universe is held together by a handful of invisible threads. These threads, the fundamental forces of nature, are the quiet architects of reality. They do not announce themselves with spectacle or sound, but their influence is everywhere, guiding the interactions of every atom, every star, every galaxy. Through their patient, persistent work, the universe takes shape, its patterns and structures emerging from the interplay of these unseen powers. The story of the forces begins with gravity, the most familiar and yet the most mysterious. Gravity is the gentle pull that draws objects together, the force that keeps planets in orbit around stars, moons circling planets, and galaxies bound in their majestic spirals. It is the architect of the cosmos on the grandest scales, shaping the structure of the universe from the smallest pebble to the largest cluster of galaxies. Gravity's touch is subtle, its strength weak compared to the other forces, but its reach is infinite, extending across the vastness of space and time. Gravity's origins lie in the curvature of space itself. According to Einstein's theory of general relativity, mass and energy bend the fabric of space-time, creating the effect we perceive as gravity. Objects follow the curves and contours of this fabric, their paths shaped by the presence of mass. The sun bends space around it, guiding the planets in their orbits. The Earth bends space, holding the moon in its embrace. Even light, though massless, follows the curves of space, its path bent by the gravity of stars and galaxies. Gravity is the silent sculptor, shaping the universe with a patient, invisible hand. Yet gravity is only one of the four fundamental forces. The second, electromagnetism, is the force of light and electricity, of magnetism and chemical bonds. It is the architect of the everyday world, governing the interactions of charged particles, the flow of currents, the behavior of atoms and molecules. Electromagnetism is responsible for the warmth of sunlight, the colors of the rainbow, the spark of lightning, and the gentle pull of a magnet. It is the force that binds electrons to nuclei, forming the atoms that make up all matter. Electromagnetism is carried by photons, the particles of light. When a charged particle moves, it creates a disturbance in the electromagnetic field, sending ripples outward at the speed of light. These ripples are the waves of radio, microwaves, infrared, visible light, ultraviolet, X-rays, and gamma rays, the full spectrum of electromagnetic radiation. The interactions of photons with matter give rise to the rich variety of phenomena that fill the world with color, warmth, and energy. The third force, the strong nuclear force, is the most powerful of all, but its reach is limited to the tiniest scales. It is the force that binds quarks together to form protons and neutrons, and then binds those protons and neutrons together in the nucleus of the atom. Without the strong force, the nuclei of atoms would fly apart, and the universe would be a sea of unbound particles. The strong force is the glue of matter, holding the heart of every atom together with a grip so powerful that it overcomes the repulsion of the positively charged protons. the strong force is carried by particles called gluons, which act as the messengers between quarks. Gluons themselves carry the color charge of the strong interaction, and their constant exchange creates a dynamic, ever-shifting web of connections within the nucleus. The energy of the strong force is so great that under the right conditions, it can be released in the form of nuclear reactions, fusion in the hearts of stars, fission in the splitting of heavy atoms, and the explosive power of supernova. Fourth force, the weak nuclear force, is less familiar but no less important. It is the force responsible for certain types of radioactive decay, for the transformation of one type of particle into another, and for the processes that power the Sun and other stars. The weak force is carried by the W and Z bosons, heavy particles that mediate the interactions between quarks and leptons. The weak force is essential for the fusion reactions that turn hydrogen into helium in the Sun, releasing the energy that warms the Earth and lights the sky. The weak force is also responsible for the phenomenon of neutrino emission, in which nearly massless particles are produced and sent streaming through the universe. Neutrinos are elusive, passing through matter almost without interaction, but their presence is a testament to the subtle, pervasive influence of the weak force. The interplay of the strong and weak forces, along with electromagnetism and gravity, creates the rich tapestry of interactions that shape the universe at every scale. These four forces are the foundation of all physical phenomena. Their interplay determines the structure of atoms, the behavior of molecules, the formation of stars and galaxies, and the evolution of the cosmos itself. Each force has its own character, its own range and strength, its own role in the unfolding story of the universe. Together, they create a balance, a harmony that allows for the emergence of complexity, order, and life. The search for unity among the forces has been a central quest in physics. The electromagnetic and weak forces have been shown to be two aspects of a single electroweak force, unified at high energies in the early universe. The strong force, too, may be unified with the electroweak force at even higher energies, in a grand synthesis known as a grand unified theory. Gravity, however, remains apart, its unification with the other forces an unsolved mystery, a challenge that continues to inspire new ideas and experiments. The forces are not only the architects of the physical world, but also the storytellers of its history. In the earliest moments after the Big Bang, the forces were united, their differences hidden by the extreme energies of creation. As the universe cooled, the forces separated, each taking on its distinct character, each shaping the evolution of matter and energy in its own way. The history of the universe is the history of the forces, their interplay and separation, their balance and tension. The influence of the forces is felt in every corner of the cosmos. In the heart of a star, the strong and weak forces drive the fusion reactions that create light and heat. In the swirling arms of a galaxy, gravity guides the motion of stars and gas, shaping the patterns of spiral and elliptical forms. In the bonds between atoms, electromagnetism creates the structures of molecules, the chemistry of life, the colors and textures of the world. In the decay of radioactive elements, the weak force transforms matter, releasing energy and creating new possibilities. The forces are also the architects of change. They govern the cycles of creation and destruction, the birth and death of stars, the formation and dissolution of galaxies, the transformation of elements in the crucible of supernova. The universe is a place of constant motion, every change a result of the interplay of the forces, every moment a step in the ongoing evolution of reality. The subtlety of the forces is matched by their power. Gravity, though weak, shapes the destiny of galaxies and the expansion of the universe. The strong force, though limited in range, holds the heart of every atom together. Electromagnetism, though invisible, fills the world with light and energy. The weak force, though elusive, drives the processes that power the stars and create the elements of life. Each force is essential. Each plays its part in the grand design. The forces are also the architects of possibility. Their balance and interplay allow for the emergence of complexity, for the formation of structures and patterns, for the evolution of life and consciousness. The universe is not a random collection of particles, but a system governed by laws and forces, by relationships and connections. The beauty of the cosmos lies in its order, its harmony, its capacity for change and growth. The search for understanding the forces is a journey into the heart of reality. It is a journey that reveals the unity of nature, the interconnectedness of all things, the subtlety and elegance of the laws that govern the world. It is a journey that invites wonder, curiosity, and humility, a reminder that the universe is more mysterious and beautiful than we can ever fully comprehend. The forces are not static, but dynamic, their effects changing with the conditions of the universe. In the early moments after the Big Bang, the energies were so high that the differences between the forces were blurred, their unity hidden beneath the surface. As the universe cooled, the forces separated, their distinct characters emerging, their roles in the unfolding story becoming clear. The history of the universe is a history of symmetry and breaking, of unity and diversity, of the emergence of order from chaos. The quiet architects of reality continue their work, shaping the evolution of the cosmos with patience and persistence. Their influence is felt in every atom, every star, every galaxy, every living thing. The universe is a place of connection, every part linked to the whole by the invisible threads of the forces. The patterns that emerge are not random, but the result of deep, underlying order, a testament to the power and beauty of the forces that shape reality. As the chapter of the quiet architects unfolds, the universe stands as a testament to the power of connection and the beauty of transformation. The forces, though invisible, are the foundation of all things, the architects of the cosmos, the storytellers of its history. Their interplay creates the balance and harmony that allows for the emergence of complexity, order, and life. The journey continues as the forces guide the formation of galaxies and stars, the chemistry of creation, the cycles of birth and death. The universe, ever patient, continues its gentle evolution, each moment a step in the unfolding story of existence, each force a note in the ongoing music of creation. The universe, shaped by the quiet architects of the fundamental forces, continues its slow, patient unfolding. Across the vastness, galaxies gather and drift, stars are born and die, and the elements forged in ancient furnaces are scattered and reassembled in endless cycles. Yet beneath the visible tapestry of stars and galaxies, a deeper structure emerges, a structure woven from the invisible threads of gravity and dark matter, connecting all things in a vast, cosmic web. This web is not made of silk or string, but of matter and energy, of galaxies and gas, of forces and fields. It stretches across the universe, its filaments spanning hundreds of millions of light years, its nodes marking the locations of galaxy clusters, its voids vast regions of emptiness where few galaxies reside. The cosmic web is the largest structure in the universe, a network that binds together everything from the smallest star to the largest supercluster. The story of the cosmic web begins in the earliest moments after the Big Bang, when the universe was a nearly uniform sea of matter and energy. Tiny fluctuations in density, imprinted by quantum processes in the first fractions of a second, provided the seeds for all future structure. As the universe expanded and cooled, gravity began to amplify these fluctuations, drawing matter into denser regions and leaving behind vast, empty voids. Over billions of years, these regions grew, merging and connecting to form the intricate patterns of the cosmic web. Galaxies are not scattered randomly through space, but are found along the filaments of the web, clustered at the intersections. where the filaments meet. These clusters are the largest gravitationally bound structures in the universe, containing thousands of galaxies, vast clouds of hot gas, and enormous halos of dark matter. The spaces between the filaments are immense, stretching for hundreds of millions of light years, their emptiness a testament to the power of gravity to shape the cosmos. The cosmic web is not static, but dynamic, its filaments and nodes constantly evolving as galaxies move, merge, and grow. The flow of matter along the filaments feeds the growth of clusters, while the expansion of the universe stretches the web ever outward. The patterns of the web are revealed in the distribution of galaxies, in the maps of cosmic microwave background radiation, and in the gravitational lensing of distant light. Each observation adds to the picture, revealing the interconnectedness of all things. Dark matter, though invisible, plays a crucial role in the formation and evolution of the cosmic web. Its gravity shapes the distribution of galaxies, guiding the flow of gas and the formation of stars. Without dark matter, the filaments would not form, the clusters would not grow, and the universe would be a very different place. The presence of dark matter is inferred from its effects on the motion of galaxies, the bending of light, and the patterns of the cosmic web itself. The cosmic web is also a web of energy. As matter flows along the filaments, it heats the gas, creating vast reservoirs of hot plasma that fill the spaces between galaxies. Shocks and turbulence stir the gas, driving the formation of new stars and galaxies. The energy released by supernova, by the accretion of matter onto black holes, and by the collisions of galaxies is carried along the filaments, shaping the evolution of the web. Within the filaments, galaxies are not isolated, but interact with their neighbors in a complex dance. Gravity draws galaxies together, triggering mergers and collisions that reshape their structures and fuel bursts of star formation. The exchange of gas and stars between galaxies enriches the intergalactic medium, spreading the elements forged in stars across the web. The cosmic web is a network of relationships, every part influencing and being influenced by the rest. The interconnectedness of the cosmic web is mirrored on smaller scales. Within galaxies, stars are bound together by gravity, their orbits shaped by the mass and structure of the galaxy. Within star clusters, stars interact through close encounters, exchanging energy and momentum in a slow, intricate dance. Within planetary systems, planets and moons are linked by gravity, their motions, governed by the same laws that shape the cosmos. The patterns of the cosmic web are echoed in the patterns of life. The cycles of birth and death, of creation and destruction, of connection and separation, are found at every scale, from the smallest atom to the largest galaxy. The universe is a place of relationships, of networks and systems, of parts and wholes. Every atom in every living thing was once part of a star. Every star is part of a galaxy. Every galaxy is part of the cosmic web. The study of the cosmic web is a study of connection. Astronomers map the distribution of galaxies, trace the flow of gas, and measure the effects of gravity and dark matter. Computer simulations recreate the growth of the web, showing how tiny fluctuations in the early universe grew into the vast structures we see today. Observations of the cosmic microwave background reveal the imprints of the web's formation, while surveys of galaxies and clusters map its present-day structure. The cosmic web is also a web of time. The light from distant galaxies takes billions of years to reach us, carrying with it the story of the universe's past. The patterns we see today are the result of processes that began in the earliest moments, shaped by the interplay of gravity, dark matter, and energy. The web is a record of the universe's history, a map of its evolution, a testament to the power of connection. The interconnectedness of the cosmic web extends beyond the physical. The laws of physics, the constants of nature, the patterns of mathematics, All are woven into the fabric of the universe, linking the smallest and the largest, the simplest and the most complex. The universe is not a collection of isolated objects, but a system of relationships, a network of connections, a web of meaning. The beauty of the cosmic web lies in its patterns. The filaments and nodes, the clusters and voids, the flows of matter and energy, all are expressions of the underlying order of the universe. The web is a tapestry, its threads woven from the interactions of particles and forces, its patterns shaped by the laws of nature. The universe is a work of art, its beauty revealed in the structure of the web. The cosmic web is also a web of possibility. The flow of matter along the filaments creates the conditions for the formation of galaxies, stars, and planets. The exchange of energy and elements enriches the cosmos, allowing for the emergence of complexity and life. The web is a stage for the unfolding drama of creation, a network of opportunities, a field of potential. The interconnectedness of the cosmic web is a reminder of the unity of all things. Every part of the universe is linked to every other part. Every event is connected to every other event. Every moment is part of the ongoing story of existence. The web is a symbol of the deep connections that bind the cosmos together, a testament to the power of relationship and the beauty of unity. The study of the cosmic web is a journey into the heart of the universe. It is a journey that reveals the patterns of connection, the cycles of change, the emergence of order from chaos. It is a journey that invites wonder, curiosity, and awe, a reminder that the universe is more mysterious and beautiful than we can ever fully comprehend. The cosmic web is not only a structure, but a process. It is constantly evolving, its filaments growing and stretching, its nodes merging and dissolving, its patterns shifting with the flow of time. The web is a living system, its parts in constant motion, its structure shaped by the interplay of forces and matter. The universe is a place of change, every moment a step in the ongoing evolution of the web. The interconnectedness of the cosmic web is also a source of resilience. The flow of matter and energy along the filaments allows the universe to adapt and respond to change, to recover from disruptions, to maintain its structure in the face of chaos. The web is a model of balance, of harmony, of the dynamic equilibrium that allows for the emergence of complexity and life. The patterns of the cosmic web are reflected in the patterns of thought, of society, of consciousness. The networks of neurons in the brain, the webs of relationships in communities, the connections of ideas and knowledge, all are echoes of the cosmic web, expressions of the same principles of connection and emergence. The universe is a place of meaning, its patterns mirrored in the patterns of mind and life. The journey through the cosmic web is a journey of discovery. Every observation, every measurement, every simulation adds to our understanding of the universe's structure and evolution. The web is a map, a guide, a source of inspiration. It is a reminder that the universe is a place of connection, of relationship, of unity. As the chapter of the cosmic web unfolds, the universe stands as a testament to the power of connection and the beauty of pattern. The web, though invisible, is the foundation of all things, the structure that binds the cosmos together, the stage upon which the drama of creation unfolds. Its patterns are the fingerprints of the forces and processes that shape reality, its beauty a reflection of the underlying order of the universe. The journey continues as the cosmic web guides the formation of galaxies and stars, the flow of matter and energy, the cycles of creation and destruction. The universe, ever patient, continues its gentle evolution, each moment a step in the unfolding story of existence, each connection a thread in the ongoing tapestry of creation. Patterns emerge everywhere in the universe, from the spiral arms of galaxies to the delicate symmetry of a snowflake, from the orbits of planets to the branching of trees. Beneath the surface of all things, a quiet order reveals itself, a language that speaks not in words, but in numbers, shapes, and relationships. This is the language of mathematics, a silent code that underlies the cosmos, guiding the formation of structure, the unfolding of time, and the dance of energy and matter. The universe, in all its complexity, is built upon simple rules. These rules, expressed in the language of mathematics, govern the motion of planets, the growth of crystals, the flow of rivers, and the flicker of starlight. The same equations that describe the arc of a thrown stone also describe the orbit of a moon around a distant planet. The same geometry that shapes a honeycomb shapes the arrangement of atoms in a crystal lattice. Everywhere, patterns repeat, echoing across scales and through time. Mathematics is not merely a tool for describing the universe. It is woven into the very fabric of reality. The laws of physics are written in mathematical form, their elegance and simplicity a reflection of the underlying order of the cosmos. The force of gravity, the behavior of light, the structure of atoms, all are governed by equations that reveal the unity and coherence of nature. The universe is a tapestry, its threads woven from the relationships of numbers and forms. The language of mathematics is universal. It is the same everywhere, from the smallest particle to the largest galaxy, from the earliest moments of the universe to the present day. The patterns it describes are found in the arrangement of petals on a flower, the spiral of a seashell, the branching of lightning, and the ripples on a pond. The Fibonacci sequence, the golden ratio, the fractal geometry of coastlines and clouds all are expressions of the mathematical order that pervades the natural world. In the motion of the planets. The language of mathematics is clear and precise. The orbits of the planets around the sun follow the laws discovered by Kepler and Newton, their paths described by ellipses, their periods related by simple ratios. The harmony of the spheres, once a poetic idea, is revealed in the regularity of planetary motion, the resonance of orbits, the cycles of conjunction and opposition. The same laws that govern the motion of the planets also govern the motion of electrons in an atom, the oscillation of a pendulum, the vibration of a string. The patterns of mathematics are also found in the structure of matter. The arrangement of atoms in a crystal follows the rules of symmetry and repetition, creating patterns that repeat in 3 dimensions. The shapes of molecules, the folding of proteins, the structure of DNA all are governed by mathematical relationships, by angles and distances, by the balance of forces and energies. The beauty of a snowflake, the strength of a spider's web, the resilience of bone all are products of mathematical design. In the world of waves and vibrations, mathematics reveals the hidden order of sound and light, the frequencies of musical notes, the colors of the rainbow, the interference patterns of ripples on water, all are described by the mathematics of waves. The harmony of music, the beauty of color, the patterns of interference and diffraction all are expressions of the underlying order that mathematics reveals. The language of mathematics is also the language of change. Calculus, the mathematics of motion and growth, describes the changing world, the flow of time, the evolution of systems, the growth of populations, the spread of diseases, the decay of radioactive elements, the cooling of a cup of tea, all are governed by differential equations, by the interplay of rates and accumulations, by the balance of forces and flows. In the patterns of chaos and complexity, mathematics finds order in apparent disorder. The weather, the turbulence of fluids, the branching of rivers, the beating of a heart, all are examples of systems that are sensitive to initial conditions, where small changes can lead to vastly different outcomes. Yet even in chaos, patterns emerge strange attractors, fractal boundaries, self-similar structures that repeat at every scale. The mathematics of chaos reveals the hidden order in the unpredictable, the structure in the seemingly random. The universe is also a place of symmetry. The laws of physics are often invariant under transformations, rotations, reflections, translations, revealing a deep symmetry that underlies the structure of reality. Symmetry is not only a source of beauty, but a guide to understanding. The conservation of energy, momentum, and charge are all consequences of symmetry, as revealed by Noether's theorem. The patterns of symmetry are found in the shapes of molecules, the arrangement of crystals, the structure of galaxies, and the laws of nature themselves. Mathematics is the language of possibility. It allows for the exploration of worlds that may not exist, for the creation of models and simulations, for the prediction of outcomes, and the testing of ideas. The equations of physics can be solved for different conditions, revealing the range of possible behaviors, the boundaries of stability, the thresholds of change. Mathematics is a tool for discovery, a way of probing the unknown, a means of exploring the landscape of reality. The patterns of mathematics are also found in the world of information. The codes of DNA, the logic of computers, the structure of language, all are governed by mathematical principles, by the rules of combination and transformation, by the patterns of repetition and variation. The universe is a place of information, its structure and evolution shaped by the flow and processing of data, by the transmission and transformation of signals. In the study of the cosmos, mathematics is the key to understanding the expansion of the universe, the formation of galaxies, the evolution of stars. All are described by mathematical models, by equations that capture the essence of the processes at work. The patterns of the cosmic microwave background, the distribution of galaxies, the structure of the cosmic web, all are revealed through the analysis of data, the application of statistics, the search for regularity and correlation. The beauty of mathematics lies in its universality, its simplicity, its power to reveal the hidden order of the world. The same patterns are found in the growth of a fern, in the spiral of a galaxy, in the branching of a tree, and the structure of a river. Delta, in the arrangement of leaves and the formation of snowflakes. The universe is a place of pattern, of repetition and variation, of order and surprise. The language of mathematics is also a language of connection. It links the physical and the abstract, the concrete and the ideal, the real and the possible. The patterns it describes are not confined to the world of matter and energy, but extend to the world of thought and imagination, to the realms of art and music, to the structures of logic and reason. Mathematics is a bridge between worlds, a means of exploring the infinite, a way of finding unity in diversity. The patterns of mathematics are not imposed on the universe, but discovered within it. The laws of nature are not arbitrary, but reflect a deep coherence, a unity of structure and function, a harmony of parts and wholes. The universe is not a machine, but a living system, its patterns emerging from the interplay of forces and relationships, its beauty revealed in the language of mathematics. The study of mathematics is a journey of discovery, a quest to understand the patterns of the world, to find the order in the chaos, to reveal the unity in the diversity. It is a journey that invites wonder, curiosity, and awe, a reminder that the universe is more mysterious and beautiful than we can ever fully comprehend. The language of patterns is also a language of emergence. Simple rules give rise to complex behavior. Local interactions create global order. Small changes lead to large effects. The flocking of birds, the schooling of fish, the formation of crystals, the growth of cities, all are examples of emergent phenomena where the whole is greater than the sum of its parts. Mathematics reveals the principles of emergence, the rules that govern the transition from simplicity to complexity, from order to chaos and back again. The patterns of mathematics are also a source of inspiration. They are found in the designs of artists, the compositions of musicians, the structures of architects, the theories of scientists. The beauty of a mathematical proof The elegance of a geometric construction, the surprise of a paradox, all are expressions of the creative power of mathematics, its ability to reveal new possibilities, to open new worlds. The universe in all, its richness and variety, is a testament to the power of pattern. The spiral of a galaxy, the orbit of a planet, the structure of a crystal, the rhythm of a heartbeat, all are expressions of the underlying order that mathematics reveals. The language of patterns is the language of the cosmos, a silent code that speaks of unity, coherence, and beauty. As the chapter of the language of patterns unfolds, the universe stands as a testament to the power of mathematics and the beauty of order. The patterns that emerge are not random, but the result of deep underlying principles, a reflection of the unity and coherence of nature. The journey continues as the language of mathematics guides the exploration of the cosmos, the search for understanding, the quest for meaning. The universe, ever patient, continues its gentle evolution, each moment a step in the unfolding story of existence, each pattern a thread in the ongoing tapestry of creation. Time moves quietly through the universe, a silent current that shapes the unfolding of all things. It is not seen or touched, yet its presence is felt in every change, every motion, every transformation. The flow of time is the backdrop against which the cosmos evolves, a gentle river that carries galaxies, stars, and worlds from one moment to the next. In the language of the universe, time is both an arrow and a cycle, a force that moves forward and a rhythm that repeats. The arrow of time points in a single direction, from past to future, from what has been to what will be. This direction is marked by change, by the unfolding of events, by the increase of entropy, the gradual spreading out of energy, the tendency of systems to move from order to disorder. The arrow of time is seen in the cooling of a hot cup of tea, the fading of a star's light, the crumbling of mountains, the aging of living things. It is the reason why memories are of the past, not the future, why causes precede effects, why the universe moves ever onward. Yet time is also a cycle, a pattern that repeats in endless variations. The orbits of planets, the turning of seasons, the rise and fall of tides, the beating of a heart, all are cycles, rhythms that mark the passage of time in regular intervals. The universe is filled with cycles, from the oscillation of atoms to the rotation of galaxies, from the birth and death of stars to the ebb and flow of cosmic structures. These cycles are the heartbeat of the cosmos, the music of existence, the patterns that give shape to the flow of time. The nature of time has long been a mystery, a subject of wonder and contemplation. In the earliest moments of the universe, time and space were inseparable, woven together in the fabric of space-time. The expansion of the universe is also the expansion of time, the stretching of the cosmic clock, the unfolding of the story of creation. The passage of time is not the same everywhere. It is shaped by gravity, by motion, by the curvature of space. Near a massive star or a black hole, time slows, its flow stretched by the warping of space-time. For a traveler moving at the speed of light, time stands still. A journey completed in an instant. The relativity of time is one of the great discoveries of modern physics. Einstein's theories revealed that time is not absolute, but relative, its passage dependent on the observer's frame of reference. Two clocks, moving at different speeds or in different gravitational fields, will tick at different rates. The twin paradox, the slowing of time for fast-moving objects, the dilation of time near massive bodies, all are consequences of the relativity of time, the flexibility of the cosmic clock. Yet for all its relativity, time remains a constant companion, a thread that connects the moments of existence. The ticking of atomic clocks, the decay of radioactive elements, the oscillation of light waves, all are measures of time, standards that allow for the comparison of events, the coordination of actions, the synchronization of systems. The measurement of time is a human endeavor, a way of making sense of the flow, of marking the passage, of finding order in the stream of change. The cycles of time are found everywhere in nature. The day and night, the waxing and waning of the moon, the changing of the seasons, the migration of animals, the flowering of plants, all are responses to the rhythms of the cosmos, the cycles of light and darkness, warmth and cold, abundance and scarcity. The cycles of time are also found in the lives of stars, in the pulsation of variable stars, the explosion of supernova, the formation and dissolution of galaxies. The universe is a place of cycles, of repetition and renewal, of beginnings and endings that flow into one another. The arrow of time is also a story of memory and anticipation. The past is recorded in the patterns of the present, in the arrangement of atoms, the structure of rocks, the rings of trees, the layers of ice. The future is anticipated in the cycles of nature, the return of the seasons, the growth of new life, the unfolding of possibilities. The flow of time is the flow of information, the transmission of patterns from one moment to the next, the preservation of order in the midst of change. The cycles of time are not perfect. They are marked by variation, by irregularity, by the influence of chance and chaos. The orbits of planets are perturbed by the gravity of other bodies. The rhythms of life are shaped by the unpredictability of weather. The cycles of stars are influenced by the interactions of galaxies. Yet even in the midst of chaos, patterns emerge, cycles repeat, order arises from disorder. The universe is a place of resilience, of adaptation, of the persistence of cycles in the face of change. The flow of time is also a flow of energy. The sun rises and sets, its energy driving the cycles of weather, the growth of plants, the rhythms of life. The energy of stars is released in cycles of fusion and radiation. The energy of galaxies is distributed in cycles of formation and dissolution. The universe is a place of flow, of movement, of the transfer and transformation of energy across scales and systems. The arrow of time is a source of creativity, of novelty, of the emergence of new forms and structures. The universe is not static, but dynamic, its patterns evolving, its cycles unfolding, its possibilities expanding. The flow of time allows for the growth of complexity, the emergence of life, the evolution of consciousness. The universe is a place of becoming, of transformation, of the continual unfolding of new possibilities. The cycles of time are also cycles of connection. The return of the seasons, the migration of animals, the flowering of plants, all are responses to the rhythms of the cosmos, the cycles of light and darkness, warmth and cold, abundance and scarcity. The cycles of time link the parts of the universe, creating networks of relationship, patterns of interaction, webs of meaning. The measurement of time is a human endeavor, a way of making sense of the flow, of marking the passage, of finding order in the stream of change. Calendars and clocks, sundials and hourglasses, atomic clocks and pulsars, all are tools for measuring time, for coordinating actions, for synchronizing systems. The measurement of time is also a way of connecting the present to the past and the future, of creating a sense of continuity, of belonging to the flow of history. The cycles of time are also cycles of renewal. The return of the seasons, the rebirth of life, the regeneration of ecosystems, all are expressions of the resilience of the universe, the capacity for renewal, the persistence of order in the midst of change. The cycles of time are a source of hope, of possibility, of the promise of new beginnings. The arrow of time is a reminder of the impermanence of all things, of the inevitability of change, of the passage from birth to death, from creation to dissolution. Yet within the flow of time, there is also continuity, persistence, the survival of patterns, the endurance of relationships. The universe is a place of both change and stability, of both flow and structure, of both arrow and cycle. The nature of time is a mystery, a subject of wonder and contemplation. Is time a fundamental property of the universe, or an emergent phenomenon, a product of the relationships between events? Is the flow of time an illusion, a consequence of our perception, or a real feature of the cosmos? The questions remain, inviting exploration, reflection, and awe. The flow of time is also a flow of consciousness. The experience of time, the sense of past, present, and future, the awareness of change and continuity, all are aspects of consciousness, of the mind's engagement with the world. The flow of time is the flow of experience, the unfolding of awareness, the journey of the self through the landscape of existence. The cycles of time are also cycles of meaning. The return of the seasons, the repetition of rituals, the commemoration of anniversaries, all are ways of creating meaning, of connecting the present to the past and the future, of finding purpose in the flow of time. The cycles of time are a source of identity, of belonging, of connection to the larger patterns of the universe. The arrow of time is a source of direction, of purpose, of the drive to create, to explore, to understand. The flow of time is the flow of possibility, the opening of new paths, the emergence of new forms. The universe is a place of potential, of opportunity, of the continual unfolding of new realities. The cycles of time are also cycles of learning. The repetition of experience, the accumulation of knowledge, the refinement of understanding, all are products of the cycles of time, the patterns of repetition and variation, the interplay of memory and anticipation. The cycles of time are a source of wisdom, of growth, of the deepening of understanding. The flow of time is the flow of life. The rhythms of the heart, the cycles of breath, the growth and decay of cells, the aging of the body, all are expressions of the flow of time, the passage from birth to death, from creation to dissolution. The flow of time is the flow of love, of relationship, of the connections that bind us to one another and to the universe. The cycles of time are also cycles of the cosmos. The birth and death of stars, the formation and dissolution of galaxies, the expansion and contraction of the universe, all are cycles, rhythms, patterns that mark the passage of cosmic time. The universe is a place of cycles, of repetition and renewal, of the continual unfolding of new possibilities. As the chapter of time's gentle flow unfolds, the universe stands as a testament to the power of time and the beauty of change. The arrow and the cycle, the flow and the rhythm, the passage and the return, all are expressions of the underlying order of the cosmos, the patterns that give shape to the unfolding story of existence. The journey continues as the flow of time guides the evolution of the cosmos, the emergence of complexity, the unfolding of life and consciousness. The universe, ever patient, continues its gentle evolution, each moment a step in the ongoing dance of time, each cycle a thread in the tapestry of creation. In the quiet aftermath of stars' fiery lives, the universe is seeded with the elements of possibility. Carbon, oxygen, nitrogen, and other atoms, forged in the hearts of ancient suns, drift through the darkness, carried on cosmic winds and scattered by supernova. These atoms, once part of distant stars, now wander the interstellar medium, mingling with hydrogen and helium, gathering in clouds that span light years. The chemistry of creation begins in these silent, cold expanses, where the building blocks of life are patiently assembled, one bond at a time. Within the vast molecular clouds, dust grains provide surfaces for atoms to meet and react. Temperatures drop to just a few degrees above absolute zero, and the darkness is deep, yet even here, chemistry is at work. Hydrogen atoms, the simplest and most abundant, pair up to form molecular hydrogen, the most basic molecule in the universe. On the surfaces of dust grains, more complex reactions occur. Oxygen and hydrogen combine to form water, carbon and oxygen create carbon monoxide, and nitrogen finds partners in ammonia and other simple compounds. These molecules, though small, are the first steps on the long road to complexity. Cosmic rays, high-energy particles from distant events, pass through these clouds, providing the energy needed to break bonds and spark new reactions. Ultraviolet. Light from nearby stars also plays a role, driving photochemical processes that create and destroy molecules. The chemistry of the cosmos is a balance of creation and destruction, of assembly and disassembly, of the slow accumulation of complexity. In the face of constant change. As molecular clouds collapse under gravity, their centers grow denser and warmer. In these nurseries, new stars are born, and with them, new planetary systems. The heat and radiation from young stars drive further chemical reactions, transforming simple molecules into more complex ones. Disks of gas and dust swirl around newborn stars, and within these disks, grains stick together, forming pebbles, rocks, and eventually planets. The chemistry of creation continues on these growing worlds, as elements and molecules are sorted, concentrated, and transformed by heat, pressure, and time. On young planets, the stage is set for even greater complexity. Volcanic eruptions release gases into the atmosphere. Lightning and ultraviolet light provide energy for new reactions, and water, delivered by comets and asteroids, creates a medium for molecules to move and interact. The surface of a planet is a laboratory, a place where the chemistry of the cosmos meets the conditions of a world, and new possibilities emerge. The formation of molecules is a story of connection. Atoms join together, sharing electrons, forming bonds that are both strong and flexible. The simplest molecules, hydrogen, water, methane, ammonia, are the foundation, but the chemistry of creation does not stop there. Carbon, with its ability to form 4 bonds, becomes the central player in the drama of complexity. Chains of carbon atoms link together, creating hydrocarbons, alcohols, acids, and more. Rings of carbon form the basis of sugars, nucleotides, and other essential molecules. The diversity of carbon chemistry is the key to life's potential. The reason why life as we know it is built on this remarkable element. In the primordial soup of a young planet, molecules gather and interact, forming ever more complex structures. Amino acids, the building blocks of proteins, assemble from simpler precursors. Nucleotides, the components of RNA and DNA, form through a series of chemical steps, each one guided by the laws of thermodynamics and the availability of energy. Lipids, with their hydrophobic tails and hydrophilic heads, organize themselves into membranes, creating boundaries that separate inside from outside, self from environment. The chemistry of creation is a process of emergence. Simple molecules combine to form more complex ones, and at a certain threshold, new properties appear. A chain of amino acids becomes a protein, capable of folding into intricate shapes and performing specific functions. A sequence of nucleotides becomes a gene, a carrier of information, a template for replication and evolution. A collection of lipids forms a vesicle, a primitive cell, capable of maintaining its own internal environment and responding to changes in the world outside. The origins of life are shrouded in mystery, but the chemistry that makes life possible is universal. The same elements and molecules are found throughout the cosmos, in meteorites, in the atmospheres of distant planets, in the icy moons of the outer solar system. The building blocks of life are not unique to Earth. They are the products of cosmic processes, the result of the same chemistry that shapes stars and galaxies. The potential for life is written into the fabric of the universe, a possibility that emerges wherever the right conditions are found. The chemistry of creation is also a story of cycles. Elements are recycled through stars, planets, and living things, passing from one form to another in an endless loop. Water evaporates from oceans, falls as rain, flows in rivers, and returns to the sea. Carbon is fixed by plants, consumed by animals, released by respiration and decay, and taken up again by new life. Nitrogen cycles through the atmosphere, soil, and living organisms, transformed by bacteria and lightning, by fire and water. The cycles of chemistry are the cycles of life, the rhythms that sustain the biosphere and connect all living things. The emergence of life is a process of self-organization. Molecules assemble into networks, networks into systems, systems into organisms. Each level of organization brings new properties, new possibilities, new forms of complexity. The chemistry of creation is not a random process, but a guided one, shaped by the laws of physics, the availability of energy, and the constraints of the environment. The patterns that emerge are the result of selection, adaptation, and feedback, of the interplay between chance and necessity. The chemistry of life is a chemistry of information. DNA and RNA store the instructions for building and maintaining. An organism, encoding the sequences of amino acids that make up proteins, the catalysts and machines of the cell. The flow of information from DNA to RNA to protein is the central dogma of biology, the process by which the instructions of life are read, copied, and executed. The chemistry of information is also a chemistry of error and correction, of mutation and repair, of the balance between stability and change. The origins of life are also the origins of metabolism, the set of chemical reactions that sustain an organism that allow it to grow, reproduce, and respond to its environment. Metabolism is the chemistry of energy, the process by which molecules are broken down to release energy, or built up to store it. The cycles of metabolism, glycolysis, the citric acid cycle, photosynthesis, respiration are the engines of life. The means by which organisms capture, transform, and use energy. The chemistry of creation is a story of resilience. Life emerges in the most unlikely places, in the depths of the ocean, in the cracks of rocks, in the frozen deserts of Antarctica, in the boiling springs of Yellowstone. The molecules of life are robust, capable of withstanding extremes of temperature, pressure, and radiation. The chemistry of life is a chemistry of adaptation, of finding ways to survive and thrive in a changing world. The building blocks of life are also the building blocks of diversity. The same set of elements and molecules can give rise to an almost infinite variety of forms, from the simplest bacteria to the most complex plants and animals. The chemistry of creation is a chemistry of possibility, of the exploration of new forms, new functions, new ways of being alive. The story of molecules and life's beginnings is a story of connection. Every atom in every living thing was once part of a star, every molecule a product of cosmic processes, every cell a participant in the cycles of chemistry that sustain the biosphere. The chemistry of creation is a thread that links the past to the present, the cosmos to the cell, the universe to the individual. The emergence of life is not the end of the story, but the beginning of a new chapter. The chemistry of creation continues in every living cell, in every breath, in every heartbeat. The cycles of chemistry are the cycles of life, the rhythms that sustain the biosphere and connect all living things. The universe, ever patient, continues its gentle evolution, each moment a step in the unfolding story of existence, each molecule a thread in the tapestry of creation. As the chapter of the chemistry of creation unfolds, the universe stands as a testament to the power of connection and the beauty of transformation. The molecules that make up life are the products of cosmic processes, the result of the same chemistry that shapes stars and galaxies. The journey continues, as the chemistry of creation gives rise to new forms, new possibilities, new expressions. Of the universe's hidden language, from the quiet chemistry of creation, life emerges as a new expression of the universe's hidden language. The molecules that once drifted through interstellar clouds, forged in the hearts of ancient stars, now find themselves woven into the intricate patterns of living cells. Life, in all its forms, is a testament to the universe's capacity for complexity, resilience, and connection. It is not an isolated phenomenon, but a natural outgrowth of the same processes that shape galaxies, stars, and planets, a continuation of the cosmic story, written in the language of atoms and molecules. A small blue planet orbiting an ordinary star, life takes root in the ancient seas. Simple cells encased in delicate membranes float in the primordial waters, drawing energy from sunlight, from chemical gradients, from the heat of the earth itself. These first living things are humble, yet within them lies the potential for all the diversity that will follow. Their chemistry is universal, their structures shaped by the same laws that govern the stars. The boundary between living and non-living is thin, a gradual transition from the self-organization of molecules to the self-sustaining cycles of metabolism and replication. Over time, life diversifies and adapts, exploring every niche and possibility. Cells learn to harness the energy of sunlight through photosynthesis, transforming the atmosphere and filling the world with oxygen. New forms arise, multicellular organisms, each cell a specialist, working in concert with its neighbors. The first plants and animals appear, their bodies built from the same elements, their lives governed by the same cycles of birth, growth, and decay. The tree of life branches and spreads, its roots deep in the chemistry of the cosmos, its leaves. Reaching toward the future dot, the interconnectedness of life is evident in every ecosystem, every web of relationships. Plants capture sunlight and turn it into food. Animals eat plants and each other, returning nutrients to the soil. Fungi and bacteria break down dead matter, recycling the elements for new generations. The cycles of matter and energy that sustain life are the same cycles that shape the universe, the flow of atoms and molecules, the transformation of energy, the balance of creation and destruction. Life is not separate from the cosmos, but a part of its ongoing evolution, a participant in the great cycles of change. The diversity of life is a reflection of the universe's creativity. From the simplest bacteria to the most complex mammals, every organism is a unique solution to the challenges of survival and reproduction. The forms and functions of life are shaped by the environment, by the availability of resources, by the pressures of competition and cooperation. Evolution, the process by which life changes over time, is a natural consequence of variation, inheritance, and selection, a cosmic experiment in adaptation and innovation. Within each living cell, the chemistry of life continues, a dance of molecules and energy, of information and structure. DNA stores the instructions for building and maintaining the organism, while proteins carry out the work of the cell, catalyzing reactions, transporting materials, responding to signals. The flow of information from DNA to RNA to protein is the central dogma of biology, a process as fundamental as the fusion of hydrogen in stars or the orbit of planets around the sun. The machinery of life is intricate, yet its principles are universal. Its patterns echoed in the structure of galaxies, and the cycles of the cosmos. Life is also a story of cooperation and symbiosis. Organisms form partnerships, sharing resources, protecting each other, creating new possibilities. The mitochondria that power animal cells were once free-living bacteria, now integrated into the fabric of the cell. Plants and fungi form mycorrhizal networks, exchanging nutrients and information through underground webs. Coral reefs, rainforests, and grasslands are all examples of communities where the whole is greater than the sum of its parts, where diversity and connection create resilience and abundance. The emergence of consciousness is one of life's most profound mysteries. The ability to sense, to respond, to learn, to remember, to feel, these are the hallmarks of sentient life, the qualities that allow organisms to navigate their worlds, to form relationships, to create meaning. The brain, with its billions of neurons and trillions of connections, is a marvel of complexity, a network that mirrors the patterns of the cosmos. Consciousness is not an isolated phenomenon, but an emergent property of matter and energy, a new way for the universe to know itself. Life's place in the universe is both humble and extraordinary. On one hand, life is a natural outcome of the same processes that shape stars and galaxies, a product of chemistry and physics, of chance and necessity. On the other hand, life brings something new to the cosmos, a capacity for awareness, for experience, for reflection, for wonder. Through life, the universe becomes conscious of itself, able to ask questions, to seek understanding, to create beauty and meaning. The interconnectedness of life extends beyond the boundaries of Earth. The elements that make up living things are found throughout the cosmos, in the atmospheres of distant planets, in the icy moons of the outer solar system, in the dust between the stars. The building blocks of life, amino acids, sugars, nucleotides, have been found in meteorites and comets, suggesting that the chemistry of life is not unique to our world. The search for life beyond Earth is a search for connection, for kinship, for the recognition that we are part of a larger community of being. The resilience of life is a testament to its adaptability. Organisms thrive in the most extreme environments, at the bottom of the ocean, in the frozen deserts of Antarctica, in the boiling springs of Yellowstone, in the radioactive ruins of Chernobyl. Life finds a way, adapting to new challenges, evolving new forms, exploring new possibilities. The history of life on Earth is a history of survival, of extinction and renewal, of the continual emergence of novelty and complexity. The cycles of life are cycles of transformation. Birth and death, growth and decay, creation and destruction. These are the rhythms that sustain the biosphere, the patterns that connect all living things. The atoms that make up a living body are borrowed from the world, used for a time, and then returned to the earth, the air, the water. The cycles of matter and energy that sustain life are the same cycles that shape the stars, the planets, the galaxies. Life is a participant in the great dance of the cosmos, a thread in the tapestry of creation. The story of life is also a story of meaning. Through life, the universe becomes a place of value, of purpose, of relationship. The bonds between parent and child, between friends and lovers, between humans and the natural world, these are expressions of the deep connections that bind all things. The search for meaning, for understanding, for belonging, is a natural outgrowth of life's capacity for awareness and reflection. The emergence of culture, language, art, and science is a continuation of the cosmic story. Through culture, life creates new forms of connection, new ways of sharing knowledge, new expressions of beauty and creativity. Language allows for the transmission of information across generations, the accumulation of wisdom, the creation of shared meaning. Art expresses the inner life of the mind, the emotions and experiences that make us human. Science seeks to understand the patterns of the world, to reveal the hidden order of the cosmos, to decode the universe's hidden language. The place of life in the universe is a place of responsibility. As conscious beings, we have the capacity to shape the world, to care for the earth, to protect the diversity and beauty of life. The choices we make, the actions we take, have consequences that ripple through the web of life, affecting not only ourselves, but all living things. The interconnectedness of life is a reminder of our dependence on the world, of our kinship with all beings, of our role as stewards of the planet. The search for life beyond Earth is a search for connection, for understanding, for the recognition that we are not alone. The discovery of even the simplest life on another world would be a profound affirmation of the universality of life, a reminder that the cosmos is a place of possibility, of creativity, of endless potential. The search for life is also a search for meaning, for the recognition that we are part of a larger story, a participant in the ongoing evolution of the universe. The living cosmos is a place of wonder. The diversity of life, the complexity of ecosystems, the emergence of consciousness, the creation of culture, all are expressions of the universe's capacity for novelty, for beauty, for connection. Life is not an accident, but a natural outcome of the processes that shape the cosmos, a continuation of the story that began in the hearts of stars and the depths of space. As the chapter of the living cosmos unfolds, the universe stands as a testament to the power of connection and the beauty of transformation. Life, in all its forms, is a reflection of the cosmos, a participant in the cycles of matter and energy, a bearer of meaning and possibility. The journey continues as life explores new worlds, creates new forms, and seeks to understand its place in the universe's hidden language. The story of life on Earth is inseparable from the story of the planet, itself a world shaped by the interplay of air, water, and land, where subtle balances sustain the conditions for life's flourishing. The atmosphere and the oceans, vast and ever-moving, are the great mediators of this balance, their cycles and currents weaving together the elements of climate, weather, and habitability. In their gentle dance, they create a world where life can thrive, adapt, and evolve. The atmosphere is a thin veil, a delicate mixture of gases that wraps the planet in a protective embrace. Nitrogen and oxygen dominate, but traces of argon, carbon dioxide, water vapor, and other gases play crucial roles in regulating temperature, filtering sunlight, and supporting the cycles of life. The atmosphere shields the surface from harmful radiation, moderates extremes of heat and cold, and carries the breath of life to every corner of the globe. Above the surface, the atmosphere is layered troposphere, stratosphere, mesosphere, thermosphere, exosphere, each with its own character, its own patterns of temperature and movement. The troposphere, closest to the ground, is the realm of weather, where clouds form, winds blow, and rain falls. Here, the energy of the sun drives the cycles of evaporation and condensation, the formation of storms, the gentle drift of snowflakes, the rush of hurricanes. The stratosphere, higher and calmer, holds the ozone layer, a shield that absorbs ultraviolet light and protects living things from its damaging effects. The oceans, vast and deep, cover more than 2/3 of the planet's surface. They are the great reservoirs of water, heat, and life, their currents and tides shaping the climate, the weather, and the rhythms of the biosphere. The oceans absorb and store the sun's energy, distributing warmth from the equator to the poles, moderating temperatures and creating the conditions for diverse ecosystems. The movement of water driven by wind, gravity, and the rotation of the Earth creates a global conveyor belt, a system of currents that connects all the world's oceans in a single, continuous flow. The dance of atmosphere and ocean is a dance of cycles. Water evaporates from the surface, rises into the air, condenses into clouds, and falls as rain or snow. Rivers carry water back to the sea, where the cycle begins again. The carbon cycle, too, is shaped by the interplay of air and water. Carbon dioxide dissolves in the oceans, is taken up by plants and algae, is released by respiration and decay, is buried in sediments, and returns to the atmosphere through volcanic eruptions and human activity. The cycles of nitrogen, oxygen, and other elements are similarly intertwined, their flows connecting the land, the sea, the air, and all living things. The balance of Earth's climate is maintained by feedback mechanisms that stabilize or amplify changes that keep the system within the bounds of habitability. The greenhouse effect, for example, is a natural process by which certain gases trap heat in the atmosphere, keeping the planet warm enough for liquid water and life. Too little greenhouse gas, and the world would freeze. Too much, and it would overheat. The balance is delicate, maintained by the interplay of biological, geological, and chemical processes. The oceans play a crucial role in regulating climate. They absorb vast amounts of carbon dioxide, offering the atmosphere against rapid changes. They store and transport heat, moderating the extremes of temperature between day and night, summer and winter, equator and pole. The melting and freezing of polar ice, the upwelling of deep water, the mixing of surface and subsurface layers, all are part of the ocean's role as a climate regulator, a stabilizer of the planet's energy balance. The atmosphere and oceans are also the stage for the cycles of weather and climate, the movement of air masses, the formation of high and low pressure systems, the shifting of jet streams, the oscillation of ocean currents, all create patterns of weather that vary from day to day, season to season, year to year. The El Niño and La Niña cycles, the North Atlantic Oscillation, the monsoons of Asia and Africa, all are examples of the complex interactions that shape the world's climate, that bring drought and flood, heat and cold, calm and storm. Balance of Earth's systems is not static, but dynamic, always adjusting to changes in energy, chemistry, and biology. Volcanic eruptions inject ash and gases into the atmosphere, cooling the planet for years at a time. The growth and decay of forests, the rise and fall of plankton blooms, the shifting of ocean currents, all influence the composition of the atmosphere, the flow of energy, the cycles of climate. Human activity, too, has become a force in the balance, altering the chemistry of the air and water, changing the patterns of land use, introducing new feedbacks and uncertainties. The dance of atmosphere and ocean is also a dance of life. The air carries pollen, spores, seeds, and insects across continents and oceans, connecting ecosystems and spreading diversity. The oceans are home to vast communities of plankton, the foundation of the marine food web, whose photosynthesis produces much of the world's oxygen and absorbs much of its carbon dioxide. The migration of whales, the spawning of fish, the flight of birds, all are shaped by the cycles of air and water, by the patterns of wind and current, by the rhythms of the planet. The balance of Earth's systems is maintained by a web of feedbacks and interactions. Plants take up carbon dioxide and release oxygen, cooling the planet and supporting animal life. Animals breathe oxygen and release carbon dioxide, fueling the growth of plants. Microbes in the soil and ocean transform nitrogen, making it available to plants and animals, closing the loop of the nitrogen cycle. The cycles of water, carbon, nitrogen, and other elements are interconnected, each influencing the others, each contributing to the stability and resilience of the biosphere, the atmosphere. And oceans are also the record keepers of the planet's history. Layers of ice in Antarctica and Greenland preserve bubbles of ancient air, revealing the composition of the atmosphere over hundreds of thousands of years. Sediments on the ocean floor record the changes in temperature, chemistry, and life over millions of years. Tree rings, coral skeletons, and cave deposits all hold clues to past climates, to the cycles of drought and flood, to the rhythms of the Earth's orbit and tilt. The balance of Earth's systems is a balance of opposites: warmth and cold, wet and dry, calm and storm, stability and change. The planet is a place of resilience, able to absorb shocks, to recover from disturbances, to maintain the conditions for life over billions of years. Yet the balance is not guaranteed. It is the result of countless interactions, of feedbacks that can stabilize or destabilize, of thresholds that can be crossed, of tipping points that can lead to rapid and irreversible change. The story of Earth's gentle balance is a story of connection. The air we breathe, the water we drink, the food we eat, all are products of the cycles of atmosphere and ocean, of the interplay of land, sea, and sky. The health of the planet is the health of its systems, the resilience of its feedbacks, the stability of its cycles. The well-being of humanity is tied to the well-being of the biosphere, to the balance of the systems that sustain life. The dance of atmosphere and ocean is also a dance of beauty. The colors of the sky at sunrise and sunset, the patterns of clouds, the shimmer of light on water, the roar of the surf, the stillness of a calm sea, all are expressions of the interplay of air and water, of energy and matter, of the cycles that shape the world. The beauty of the planet is a reflection of its balance, a sign of the harmony that sustains life. The balance of Earth's systems is a source of wonder and gratitude. The fact that the planet is habitable, that it has remained so for billions of years, that it supports such a diversity of life, is a testament to the resilience and adaptability of its systems. The cycles of atmosphere and ocean, the feedbacks that stabilize climate, the interactions that sustain life, all are reasons for awe, for respect, for care. The story of Earth's gentle balance is not just a story of the past, but a story of the future. The choices we make, the actions we take, will shape the balance of the planet for generations to come. The resilience of the biosphere, the stability of the climate, the health of the oceans and atmosphere, all depend on our ability to understand, respect, and protect the systems that sustain life. As the chapter of Earth's gentle balance unfolds, the planet stands as a testament to the power of connection and the beauty of harmony. The dance of atmosphere and ocean, the cycles of air and water, the feedbacks and interactions that sustain life, all are expressions of the underlying order of the cosmos, the patterns that give shape to the unfolding story of existence. Journey continues as the balance of Earth's systems supports the emergence of new forms, the evolution of life, the unfolding of consciousness. The planet, ever patient, continues its gentle evolution, each moment a step in the ongoing dance of air and water, each cycle a thread in the tapestry of creation. High above the shifting blue of Earth's oceans, the moon traces its patient path, a silent companion in the night sky. Its presence is constant, yet its influence is subtle, woven into the rhythms of the planet in ways both visible and hidden. The moon, born from a cataclysmic collision in the early days of the solar system, has shaped the destiny of Earth ever since, guiding the tides, marking the passage of time, and quietly nurturing the conditions for life. The story of the moon begins in violence, a collision between the young Earth and a Mars-sized body, an impact so great that it sent molten rock and debris into orbit. Over time, this material coalesced, cooling and solidifying to form the moon. From its earliest days, the moon has been a stabilizing force, its gravity anchoring Earth's tilt and slowing its rotation. The gentle tug of the moon's gravity creates the tides, the daily rise and fall of the oceans, a rhythm that has shaped the evolution of life and the contours of the land. The tides are the most visible sign of the moon's influence. As the moon orbits Earth, its gravity pulls on the oceans, drawing water toward it and creating a bulge on the side of Earth facing the moon. A second, smaller bulge forms on the opposite side, the result of the centrifugal force created by the Earth-Moon system's rotation. As Earth spins, these bulges move around the globe, creating the regular ebb and flow of the tides. The sun's gravity also plays a role, reinforcing or diminishing the tides, depending on the alignment of the three bodies. The tides are not just a curiosity. They are a force of transformation. The movement of water shapes coastlines, carves estuaries, and transports nutrients and sediments. Tidal currents mix the oceans, distributing heat and oxygen, supporting the productivity of coastal ecosystems. The intertidal zone, where land and sea meet, is a place of constant change, a habitat for countless species adapted to the rhythms of immersion and exposure. The tides have shaped the evolution of life, providing opportunities for adaptation, migration, and the emergence of new forms. The moon's influence extends beyond the tides. Its gravity stabilizes Earth's axial tilt, keeping it within a narrow range and preventing the wild swings that could lead to extreme climate changes. This stability has allowed for the regular progression of seasons, the cycles of growth and dormancy, the rhythms of migration and reproduction. The moon's presence has helped create a world where life can flourish, where the conditions for habitability are maintained over millions of years. The passage of the moon through the sky has long been a marker of time. The lunar cycle, from new moon to full and back again, is one of the oldest calendars, used by cultures around the world to track the passage of months and seasons. The phases of the moon are woven into the fabric of human life, marking the timing of festivals, the planting and harvesting of crops, the rhythms of ritual and celebration. The moon's regularity is a source of comfort, a reminder of the order and predictability of the cosmos. The moon's light, reflected from the sun, has illuminated the night for as long as life has existed on land. The gentle glow of moonlight shapes the behavior of animals, guiding the migrations of birds, the spawning of corals, the hunting of predators, and the foraging of prey. The cycles of light and darkness, of full and new moon, are cues for reproduction, navigation, and survival. The moon's presence is felt in the songs of frogs, the blooming of night flowers, the movements of insects and mammals. The moon's influence is also felt in the deep time of evolution. The tides, with their regular cycles of flooding and drying, may have provided the first opportunities for life to move from water to land. The intertidal zone is a place of challenge and opportunity where organisms must adapt to changing conditions, to the alternation of wet and dry, of light and dark. The evolution of limbs, lungs, and other adaptations for terrestrial life may have been shaped by the demands of this dynamic environment. The moon's gravitational pull is not limited to the oceans. It also affects the solid Earth, causing the crust to flex and bulge by a few centimeters as the moon passes overhead. These Earth tides are subtle, but they are a reminder of the interconnectedness of all things, of the way that even the most distant objects can influence the world in quiet, persistent ways. The moon's presence has inspired wonder, curiosity, and creativity throughout human history. Its phases have been tracked and recorded, its surface mapped and explored, its mysteries pondered by poets, scientists, and dreamers. The moon has been a symbol of change and renewal, of cycles and rhythms, of the passage of time and the constancy of nature. Its face, marked by craters and maria, is a record of the solar system's history, a testament to the forces that have shaped the planets and moons. The exploration of the moon has been a milestone in humanity's journey of discovery. The Apollo missions, the first steps on another world, the return of lunar rocks and soil, all have deepened our understanding of the moon's origins, its composition, its relationship to Earth. The study of lunar geology has revealed the processes of impact, volcanism and tectonics, the history of bombardment and resurfacing, the cycles of change that have shaped the moon over billions of years. Moon's influence is not limited to the physical world. It also shapes the inner world of imagination and meaning. The moon has been a muse for artists and writers, a symbol of mystery and romance, a guide for travelers and lovers. Its cycles are woven into the myths and legends of cultures around the world, its phases associated with fertility, transformation, and the passage of souls. The moon's presence in the sky is a reminder of the beauty and wonder of the universe, of the deep connections that bind all things. The moon's relationship with Earth is a dynamic one, marked by gradual change. The tidal forces that create. The tides also transfer energy from Earth's rotation to the moon's orbit, causing the moon to slowly drift away from Earth at a rate of about 4 centimeters per year. Over millions of years, this process has lengthened the day and changed the rhythms of the tides. The moon's influence is a reminder that nothing in the universe is static, that all things are in motion, that the dance of gravity and time shapes the destiny of worlds. The moon's gentle pull is also a source of energy. Tidal power, harnessed by humans in coastal regions, is a renewable resource, a way of capturing the energy of the moon's influence and using it to power homes and industries. The study of tides and lunar cycles has informed navigation, fishing, agriculture, and the management of coastal resources. The moon's presence is a practical as well as a poetic force, a partner in the stewardship of the planet. The moon's influence extends to the realm of science and exploration. The study of lunar geology has provided insights into the history of the solar system, the processes of planetary formation, the nature of impact cratering, and the evolution of planetary surfaces. The search for water and other resources on the moon has opened new possibilities for future exploration, for the establishment of lunar bases, for the use of the moon as a stepping stone to the planets and beyond. The moon's cycles are a source of rhythm and order in a changing world. Irregularity of its phases, the predictability of eclipses, the constancy of its presence in the sky, all are reminders of the underlying order of the cosmos, of the patterns that give shape to the unfolding story of existence. The moon's influence is a thread that connects the past to the present, the earth to the sky, the physical to the spiritual. The moon's silent influence is a testament to the power of subtlety, to the importance of gentle forces, to the beauty of connection. Its presence is a reminder that the universe is a place of relationships, of cycles and rhythms, of the interplay of forces and forms. The moon's story is the story of Earth, of life, of the ongoing dance of creation and change. As the chapter of the moon's silent influence unfolds, the universe stands as a testament to the power of connection and the beauty of rhythm. The moon, in its patient orbit, continues to shape the tides, to mark the passage of time, to nurture the conditions for life. The journey continues as the moon's influence guides the evolution of the planet, the cycles of the oceans, the rhythms of life, each moment a step in the ongoing dance of earth and sky. Beyond the familiar light of stars and the gentle pull of the moon, the universe is alive with travelers so elusive that they pass through worlds unnoticed. These are the invisible messengers, neutrinos, and cosmic rays particles that journey across the cosmos, weaving through matter and space, carrying with them the silent stories of distant cataclysms and ancient origins. Their presence is subtle, their passage almost undetectable, yet their influence is profound, connecting the smallest scales of reality to the grandest events in the universe. Neutrinos are among the most mysterious of these messengers. Born in the heart of stars, in the fiery crucibles of supernova, and in the radioactive decay of elements, neutrinos are nearly massless, chargeless, and interact so weakly with matter that trillions pass through every person each second, leaving no trace. They are the ultimate ghosts of the particle world, slipping through planets, stars, and even entire galaxies as if they were not there at all. The story of neutrinos begins in the heart of the atom, where the weak nuclear force governs. The transformation of particles. When a neutron decays into a proton, or when a proton is converted into a neutron in the core of a star, a neutrino is released, carrying away energy and momentum. In the sun, nuclear fusion produces a constant stream of neutrinos, which escape the solar core and travel outward at nearly the speed of light, reaching Earth just 8 minutes after they are born. These solar neutrinos are silent witnesses to the processes that power the stars. Messengers from the heart of creation. Detecting neutrinos is a challenge that has inspired ingenuity and patience. Because they interact so rarely with matter, vast detectors are built deep underground, shielded from cosmic rays and other sources of noise. Tanks of pure water or ice, lined with sensitive photomultiplier tubes, wait for the rare moment when a neutrino collides with an atom, producing a faint flash of light. These flashes are the signatures of neutrinos, the evidence of their passage, the whispers of the universe's hidden processes. Neutrinos come in three flavors: electron, muon, and tau, and can change from one flavor to another as they travel. A phenomenon known as neutrino oscillation. This discovery revealed that neutrinos have mass, albeit incredibly small, and opened new questions about the nature of matter and the evolution of the universe. The study of neutrinos has provided insights into the workings of the sun, the explosions of supernova, the behavior of the early universe, and the fundamental symmetries of nature. Cosmic rays are another class of invisible messengers, though their journeys are often more dramatic. Cosmic rays are high-energy particles, mostly protons, but also heavier nuclei and electrons that travel through space at nearly the speed of light. They are born in the most energetic events in the universe: the shock waves of supernova, the jets of active galactic nuclei, the collisions of neutron stars, and perhaps even more exotic sources yet to be discovered. When cosmic rays strike the Earth's atmosphere, they create showers of secondary particles, a cascade of energy that reaches the surface and even penetrates deep underground. The discovery of cosmic rays opened a new window on the universe, revealing processes and energies far beyond what could be produced on Earth. The study of cosmic rays has led to the discovery of new particles, the understanding of high-energy astrophysics, and the exploration of the limits of matter and energy. Cosmic rays are both a source of curiosity and a challenge, as their high energies can damage electronics, pose risks to astronauts, and influence the chemistry of the atmosphere. The journey of a cosmic ray is a journey through the magnetic fields of the galaxy, the turbulence of interstellar space, and the vast distances between stars. As they travel, cosmic rays are deflected by magnetic fields, their paths twisted and turned, their origins obscured. Only the highest energy cosmic rays, with energies millions of times greater than those produced in human-made accelerators, travel in nearly straight lines, pointing back to their sources. The study of these ultra-high energy cosmic rays is a quest to understand the most powerful accelerators in the universe, the engines that drive the cosmic drama. Neutrinos and cosmic rays are not isolated phenomena. They are part of the interconnected web of cosmic processes. The explosion of a supernova, for example, produces a burst of neutrinos that escape the star before the light does, providing an early warning of the event. The shock waves from the explosion accelerate particles to high energies, creating cosmic rays that travel across the galaxy. The interactions of cosmic rays with interstellar gas produce gamma rays and other secondary particles, contributing to the background radiation that fills the universe. The study of invisible messengers is a study of connection. Neutrinos link the processes of nuclear fusion in stars to the evolution of galaxies, the behavior of the early universe to the formation of elements. Cosmic rays connect the most violent events in the cosmos to the chemistry of the atmosphere, the evolution of life, and the patterns of climate. The invisible messengers are threads in the tapestry of creation, carriers of information, agents of change. The detection of neutrinos and cosmic rays requires patience, creativity, and collaboration. Experiments are built in deep mines, under mountains, in the ice of Antarctica, and even in space. Networks of detectors span the globe, searching for the rare signals that reveal the passage of these elusive particles. The data collected is analyzed by teams of scientists, who piece together the stories carried by the messengers, reconstructing the events that produced them, the journeys they have taken, and the secrets they reveal. The invisible messengers are also a source of wonder. The fact that particles can travel across the universe, through stars and planets, through the vast emptiness of space, and arrive on Earth is a testament to the unity of the cosmos. The journeys of neutrinos and cosmic rays are journeys of connection, of relationship, of the interplay of forces and energies across scales and distances. The influence of invisible messengers extends to the origins and evolution of life. Cosmic rays, for example, can trigger mutations in DNA, contributing to the diversity and adaptability of living things. The interaction of cosmic rays with the atmosphere produces isotopes such as carbon-14, which are used to date ancient artifacts and reconstruct the history of the planet. Neutrinos, by probing the core of the Sun and other stars, help us understand the processes that make life possible, the cycles of energy and matter that sustain the biosphere. The study of invisible messengers is also a study of the unknown. Many questions remain. What are the sources of the highest energy cosmic rays? What is the role of neutrinos in the evolution of the universe? Are there other, even more elusive particles waiting to be discovered? The search for answers is a journey into the heart of the cosmos, a quest to understand the hidden language of the universe. The invisible messengers are reminders of the subtlety and complexity of the cosmos. They are evidence that the universe is not only what we see, but also what we do not see. That reality is woven from both the visible and the invisible, the known and the unknown. The journeys of neutrinos and cosmic rays are journeys of discovery, of connection, of the ongoing unfolding of the universe's story. The presence of invisible messengers is also a source of humility. The fact that so much of the universe is hidden from direct observation, that so many processes occur beyond the reach of our senses, is a reminder of the limits of knowledge, the need for curiosity, the importance of wonder. The study of neutrinos and cosmic rays is a celebration of the human spirit, the drive to explore, to understand, to connect. As the chapter of invisible messengers unfolds, the universe stands as a testament to the power of connection and the beauty of subtlety. Neutrinos and cosmic rays, in their silent journeys, reveal the unity of the cosmos, the interplay of forces and energies, the patterns that give shape to the unfolding story of existence. The journey continues as the invisible messengers carry information across the universe, linking the smallest particles to the largest structures, the most distant events to the present moment. The cosmos, ever patient, continues its gentle evolution, each messenger a thread in the tapestry of creation, each journey a step in the ongoing dance of discovery. The universe, in all its visible splendor, is only a fraction of what truly exists. The stars, galaxies, and glowing nebulae that fill the night sky are but the luminous tip of a vast, hidden iceberg. Beyond the reach of ordinary sight, beyond the grasp of even the most sensitive instruments, lie the great mysteries of dark matter and dark energy, enigmatic presences that shape the cosmos in ways both subtle and profound. Their existence is inferred not from what they reveal, but from what they conceal, from the silent influence they exert on the dance of galaxies and the expansion of space itself. The story of dark matter begins with a puzzle. In the early 20th century, astronomers noticed that galaxies did not behave as expected. The stars at the edges of spiral galaxies moved far faster than could be explained by the visible mass alone. According to the laws of gravity, these stars should have flown off into space, yet they remained bound to their galaxies, orbiting at speeds that defied explanation. The same was true for clusters of galaxies, where the gravitational pull of the visible matter was insufficient to hold the clusters. Together, the solution to this puzzle was both simple and profound. There must be more matter than meets the eye. This unseen mass, dubbed dark matter, does not emit absorb, or reflect light. It is invisible to telescopes, undetectable by ordinary means, yet its gravitational influence is unmistakable. Dark matter forms vast halos around galaxies, providing the extra gravity needed to explain their rotation curves. It binds clusters of galaxies, shapes the large-scale structure of the universe, and leaves its imprint on the cosmic microwave background. The nature of dark matter remains one of the greatest mysteries in science. It is not made of the same particles as ordinary matter protons, neutrons, and electrons, but is thought to consist of as yet undiscovered particles that interact only weakly with the rest of the universe. Candidates include weakly interacting massive particles, WIMPs, axions, sterile neutrinos, and other exotic possibilities. Despite decades of searching, dark matter has not been directly detected, its presence inferred only from its gravitational effects. The search for dark matter is a journey into the unknown. Experiments deep underground, shielded from cosmic rays and background noise, seek the faintest hints of dark matter particles colliding with ordinary atoms. Telescopes scan the skies for the telltale signs of dark matter annihilation or decay. Particle accelerators probe the high-energy frontier, searching for new particles that might explain the missing mass. Each experiment is a step closer to understanding, a thread in the tapestry of discovery. Dark matter is not only a mystery, but a necessity. Without it, the universe as we know it could not exist. Galaxies would not form, stars would not gather, the cosmic web would not take shape. Dark matter is the scaffolding upon which the visible universe is built, the silent architect of structure and form. Its presence is a reminder that reality is more than what we see, that the universe is woven from both the visible and the invisible, the known and the unknown. If dark matter is the unseen mass that holds the universe together, dark energy is the unseen force that drives it apart. The discovery of dark energy was a surprise, a revelation that upended our understanding of the cosmos. In the late 20th century, astronomers measuring the expansion of the universe found that it was not slowing down as expected, but accelerating. The galaxies were not merely drifting apart. They were being pushed away from each other by a mysterious repulsive force. This force, called dark energy, is even more enigmatic than dark matter. It is not associated with any known particle or field, and its nature is still a subject of intense debate. Dark energy is thought to make up about 70% of the total energy content of the universe, dwarfing both dark matter and ordinary matter. Its effect is to stretch the fabric of space itself, causing the universe to expand at an ever-increasing rate. The evidence for dark energy comes from multiple sources. Observations of distant supernovae, the cosmic microwave background, and the large-scale structure of the universe all point to the same conclusion. The expansion of the universe is accelerating, driven by a force that acts uniformly across space and time. The simplest explanation is the cosmological constant, a term introduced by Einstein and later abandoned, only to be revived in light of new discoveries. Other possibilities include dynamic fields, modifications of gravity, or entirely new physics. The implications of dark energy are profound. If the acceleration continues, the universe will expand forever, growing colder and more diffuse, its galaxies drifting ever farther apart. The fate of the cosmos is tied to the nature of dark energy, to the balance between attraction and repulsion, between the pull of gravity and the push of expansion. The universe is a place of tension, of competing forces, of the interplay between the known and the unknown. The study of dark matter and dark energy is a study of humility. The realization that most of the universe is invisible, that our understanding is limited to a small fraction of reality, is a reminder of the vastness of the unknown. The search for answers is a journey of curiosity and wonder, a quest to uncover the hidden language of the cosmos. The influence of dark matter and dark energy is felt at every scale. Dark matter shapes the formation of galaxies, the clustering of stars, the patterns of the cosmic web. Dark energy shapes the expansion of space, the fate of the universe, the ultimate destiny of all things. Their interplay is the backdrop to the story of creation, the silent stage upon which the drama of existence unfolds. The search for dark matter and dark energy is also a search for connection. The particles and fields that make up the universe are not isolated, but part of a larger whole, a system of relationships and interactions. The visible and the invisible, the known and the unknown, the matter and the energy all are threads in the tapestry of reality, woven together by the laws of physics and the patterns of mathematics. The mysteries of dark matter and dark energy are not barriers, but invitations. They are reminders that the universe is more mysterious and beautiful than we can ever fully comprehend, that every answer leads to new questions, that the journey of discovery is never complete. The edge of understanding is not a boundary, but a horizon, a place where curiosity meets possibility, where the known meets the unknown. The study of the unseen is a celebration of the human spirit, the drive to explore, to question, to seek understanding. It is a testament to the power of observation, of inference, of imagination. The search for dark matter and dark energy is a journey into the heart of the cosmos, a quest to decode the universe's hidden language, to reveal the patterns that shape reality. The presence of dark matter and dark energy is also a source of wonder. The fact that the universe is held together by invisible mass, that its expansion is driven by an unseen force, is a reminder of the subtlety and complexity of reality. The mysteries of the cosmos are not obstacles, but opportunities, invitations to look deeper, to listen more closely, to seek the meaning behind the music dot. As the chapter of the edge of understanding unfolds, the universe stands as a testament to the power of mystery and the beauty of the unknown. Dark matter and dark energy, in their silent influence, reveal the unity of the cosmos, the interplay of forces and energies, the patterns that give shape to the unfolding story of existence. The journey continues as the search for the unseen shapes the evolution of science, the expansion of knowledge, the unfolding of curiosity. The cosmos, ever patient, continues its gentle evolution, each mystery a thread in the tapestry of creation, each question a step in the ongoing dance of discovery. Long before telescopes swept the heavens, long before satellites circled the earth, the night sky was a canvas of wonder. Ancient eyes gazed upward, tracing the slow drift of constellations, the wandering of planets, the sudden brilliance of comets and meteors. The stars became companions, storytellers, and guides, their patterns woven into the rhythms of daily life. The art of cosmic observation began not with instruments, but with curiosity, a quiet longing to understand the lights that shimmered in the darkness. The earliest observers marked the passage of time by the stars. The rising of Sirius signaled the flooding of the Nile. The appearance of the Pleiades marked the changing of seasons. Stone circles, pyramids, and temples were aligned with the solstices and equinoxes, their stones casting shadows that measured the year. The sky was a clock, a calendar, a map. Its cycles guided planting and harvest, migration and ritual. The ebb and flow of human life. As civilizations grew, so did the sophistication of their observations. Babylonian astronomers recorded the motions of planets and eclipses, developing mathematical models to predict celestial events. Chinese sky watchers cataloged comets and novae, their records stretching back millennia. In the Americas, the Maya built observatories to track Venus, their calendars rivaling those of any culture. The sky was a shared heritage, a source of knowledge and meaning, a bridge between Earth and cosmos. The invention of the telescope transformed the art of observation. Galileo's small instrument revealed mountains on the moon, moons around Jupiter, the phases of Venus, and the countless stars of the Milky Way. The universe grew larger, richer, more complex. Telescopes became windows into the unknown, tools for exploring the depths of space and time. Each new advance larger mirrors, finer lenses, more sensitive detectors brought new discoveries, new questions, new wonders. The art of observation is also the art of patience. The stars move slowly, their changes measured in years, centuries, or millennia. The light from distant galaxies began its journey long before the first humans walked the earth. To listen to the stars is to listen across time, to receive messages from the past, to witness the unfolding story of the cosmos. Astronomers wait for clear nights, for rare alignments, for the brief flash of a supernova, or the subtle dimming of a distant planet. The sky rewards those who are patient, who are attentive, who are willing to look and look again. Observation is not only about seeing, but about interpreting. The light that reaches Earth is shaped by its journey, absorbed, scattered, redshifted, and blended. Spectroscopy, the study of light spectrum, reveals the fingerprints of elements, the temperatures of stars, the motions of galaxies. Radio. Telescopes listen to the whispers of hydrogen clouds, the pulses of neutron stars, the echoes of the Big Bang. X-ray and gamma-ray observatories detect the violence of black holes and supernova, the high-energy drama of the universe. Each wavelength tells a different story. Each observation adds a new layer to our understanding. The art of cosmic observation is also the art of collaboration. No single person can watch the whole sky, or gather all the data, or solve every puzzle. Networks of telescopes span the globe, sharing observations, coordinating campaigns, combining data. Space observatories escape the blurring of Earth's atmosphere, opening new windows on the universe. Teams of scientists, engineers, and technicians work together, building instruments, analyzing data, testing theories. The search for understanding is a collective endeavor, a tapestry woven from many threads. Listening to the stars is also an act of humility. The universe is vast, its mysteries deep, its timescales immense. Each discovery reveals new questions. Each answer opens new horizons. The art of observation is a dialogue with the unknown, a conversation with the cosmos, a journey into the heart of mystery. The more we learn, the more we realize how much remains to be discovered, how much lies beyond our reach, how much we have yet to understand. The history of cosmic observation is a history of innovation. New technologies have expanded our senses, allowing us to see farther, fainter, and in new ways. The photographic plate captured the faint glow of nebulae. The charge-coupled device, CCD, revolutionized digital imaging. Adaptive optics sharpen the view through turbulent air. Interferometry combines the power of many telescopes into one. Computers sift through mountains of data, searching for patterns, anomalies, and signals. The art of observation is ever evolving, ever adapting, ever reaching for the stars. Observation is also a source of inspiration. The images returned by telescopes, spiral galaxies, glowing nebulae, star clusters, and distant worlds are works of art, windows into the beauty and diversity of the cosmos. The colors of a sunset, the arc of the Milky Way, the dance of the aurora, all are reminders of the connection between earth and sky, between observer and observed. The act of looking up is an act of wonder, a celebration of curiosity, a recognition of our place in the universe. Listening to the stars is not limited to professionals or experts. Amateur astronomers, with simple telescopes or even the naked eye, contribute to the discovery of comets, the monitoring of variable stars, the tracking of asteroids. Citizen science projects invite people around the world to classify galaxies, search for exoplanets, and map the surface of Mars. The sky belongs to everyone. Its wonders open to all who are willing to look and listen. The art of observation is also the art of storytelling. Each discovery is a new chapter, each observation a new sentence, each image a new illustration. The stories of the stars are the stories of creation and destruction, of birth and death, of cycles and change. The sky is a record of the past, a guide to the present, a map of the future. The act of listening to the stars is an act of remembering, of imagining, of dreaming. The practice of cosmic observation is a bridge between science and culture. The myths and legends of the sky, the calendars and rituals, the art and literature inspired by the stars, all are part of the human response to the cosmos. The sky is a source of meaning, a canvas for imagination, a mirror for the soul. The act of looking up is an act of connection, a way of finding our place in the universe, a way of listening to the music of the spheres. The art of observation is also a practice of care, the preservation of dark skies, the protection of observatories, the stewardship of the environment all are part of the responsibility that comes with listening to the stars. Light pollution, radio interference, and environmental degradation threaten our ability to observe, to learn, to wonder. The care of the sky is the care of the planet, the recognition that our actions shape the future of discovery. Listening to the stars is a journey without end. Each new instrument, each new technique, each new question opens new possibilities. The search for exoplanets, the mapping of dark matter, the detection of gravitational waves, all are frontiers of observation, new ways of listening to the universe. The sky is a source of endless wonder, a reminder that the story of the cosmos is still being written, that the music of the stars is still playing. The art of cosmic observation is a celebration of curiosity, patience, and wonder. It is a practice of humility, collaboration, and care. It is a journey into the unknown, a dialogue with the universe, a dance with the stars. The act of listening to the stars is an act of love, a love of knowledge, of beauty, of connection. As the chapter of listening to the stars unfolds, the universe stands as a testament to the power of observation and the beauty of discovery. The stars, in their silent music, invite us to listen, to learn, to wonder. The journey continues as the art of observation guides the exploration of the cosmos, the search for understanding, the unfolding of meaning. The universe, ever patient, continues its gentle evolution, each observation a step in the ongoing dance of discovery, each act of listening a thread in the tapestry of creation. The story of the cosmos is not only written in the stars, but also within each person who gazes up at the night sky. The atoms that make up every cell, every breath, every thought, were once forged in the hearts of ancient stars, scattered across the galaxy and gathered again on a small blue planet. The universe is not something distant or separate. It is the very substance of our being, the silent companion to every heartbeat, the quiet presence in every moment of wonder. From the earliest days, humans have looked to the heavens for meaning. The patterns of the stars became guides for navigation, calendars for planting and harvest, symbols for myth and story. The sky was a mirror for hopes and fears, a canvas for imagination, a source of comfort and awe. The constellations told stories of heroes and monsters, of love and loss, of cycles and change. The moon's phases marked the passage of time, the return of the seasons, the rhythms of life and death. The connection to the cosmos is woven into every culture, every language, every tradition. The stories of creation, the rituals of renewal, the celebrations of solstice and equinox, all are expressions of the deep bond between humanity and the universe. The sky is a source of inspiration, a reminder of the vastness beyond, a call to curiosity and exploration. The act of looking up is an act of belonging, a recognition that we are part of something greater, a participant in the unfolding story of existence. Science, too, is an expression of this connection. The quest to understand the universe is a quest to understand ourselves, to find our place in the grand scheme of things, to decode the hidden language of reality. Every discovery, every equation, every observation is a step on the journey, a thread in the tapestry of knowledge. The laws of physics, the patterns of mathematics, the cycles of chemistry and biology, all are reflections of the unity of nature, the coherence of the cosmos, the interconnectedness of all things. The universe is not only out there, but also within. The same elements that shine in the stars flow in the blood, form the bones, spark the thoughts. The patterns of the cosmos are echoed in the rhythms of the heart, the cycles of breath, the firing of neurons. The beauty of a spiral galaxy is mirrored in the spiral of a seashell, the branching of a river in the branching of a tree, the dance of planets in the dance of molecules. The universe is a fractal, its patterns repeating at every scale, its language spoken in every form. The search for meaning is a natural outgrowth of consciousness. The ability to ask questions, to seek understanding, to create beauty and purpose, is a gift of the universe to itself. Through human eyes, the cosmos sees itself. Through human minds, it contemplates its own existence. Through human hearts, it feels wonder, joy, and longing. The universe is not indifferent, but participatory, its story unfolding through the choices and actions of every being. The challenges of life are also part of the cosmic story. The struggle for survival, the experience of loss, the search for connection and belonging, all are expressions of the same forces that shape the stars and galaxies. The cycles of birth and death, of creation and destruction, of change and renewal, are the rhythms of the universe, echoed in every life, every relationship, every moment of growth and transformation. The act of reflection is a bridge between the inner and outer worlds. Meditation, contemplation, art, and music are ways of listening to the universe within, of tuning in to the subtle harmonies that connect all things. The sense of awe that arises in the presence of beauty, the feeling of unity that comes in moments of silence, the experience of transcendence that lifts the heart. These are the echoes of the cosmos, the resonance of the hidden language that shapes reality. The responsibility that comes with awareness is profound. To know that we are part of the universe is to know that our actions matter, that our choices shape the future, that our care for the planet is a form of care for ourselves. The stewardship of Earth, the protection of its diversity and beauty, the cultivation of compassion and understanding, these are acts of cosmic significance, expressions of the unity that binds all things. The search for life beyond Earth is a search for kinship, for the recognition that we are not alone, that the universe is a place of possibility and connection. The discovery of even the simplest life on another world would be a profound affirmation of the universality of life, a reminder that the cosmos is creative, abundant, and full of surprises. The search for extraterrestrial intelligence is a search for dialogue, for the sharing of stories, for the expansion of understanding and empathy. The journey of science and exploration is a journey of humility and wonder. The more we learn, the more we realize how much remains unknown, how much lies beyond the horizon, how much there is to discover. The mysteries of dark matter and dark energy, the origins of life and consciousness, the fate of the universe, all are invitations to curiosity, to patience, to the ongoing dance of discovery. The universe is a place of beauty, not only in its grandest structures, but in its smallest details. The symmetry of a snowflake, the iridescence of a butterfly's wing, the song of a bird at dawn, all are expressions of the same creativity that shapes the galaxies and stars. The appreciation of beauty is a form of participation in the cosmos, a way of honoring the patterns and relationships that give rise to existence. The act of storytelling is a way of weaving meaning from experience, of connecting the past to the present, the individual to the collective, the human to the cosmic. Myths and legends, science and philosophy, poetry and art all are ways of making sense of the universe, of finding our place in its unfolding story. The stories we tell shape our understanding, our values, our dreams, and our actions. The universe is also a place of hope. The cycles of renewal, the emergence of new forms, the resilience of life, the capacity for growth and healing, all are signs that the cosmos is not static, but dynamic, not closed, but open to possibility. The challenges of the present are opportunities for learning, for adaptation, for the creation of new patterns and relationships. The sense of connection to the cosmos is a source of strength and comfort. In moments of solitude, the stars are companions. In times of uncertainty, the cycles of nature offer reassurance. In the face of loss, the continuity of the universe provides perspective. The knowledge that we are part of something vast and enduring is a balm for the spirit, a reminder of the resilience and beauty of life. The practice of gratitude is a way of honoring the gifts of the universe, the gift of existence, of awareness, of relationship, of beauty. To give thanks for the air, the water, the sunlight, the companionship of others, the opportunity to learn and grow, is to participate in the ongoing creation of meaning. Gratitude is a form of alignment with the cosmos, a way of tuning in to the hidden language that sustains all things. The journey of life is a journey of discovery, of connection, of participation in the unfolding story of the universe. Each person is a unique expression of the cosmos, a bearer of its creativity, a participant in its evolution. The choices we make, the relationships we nurture, the beauty we create, the understanding we seek, all are ways of contributing to the ongoing dance of existence. As the chapter of the universe within unfolds, the cosmos stands as a testament to the power of connection and the beauty of meaning. The universe, in all its vastness and mystery, is also intimate and personal, present in every breath, every thought, every act of love and wonder. The journey continues as the human connection to the cosmos deepens, as the hidden language of the universe is decoded, as the story of existence is written anew in every moment. The universe, ever patient, continues its gentle evolution, each life a thread in the tapestry of creation, each moment an invitation to listen, to learn, to love, and to wonder.